Hello students, welcome to the topic 2 of the JEE Mains Crash Course series. This is your friend Sumit and today we are going to start electric charges and fields. Electric charges and fields is one of the most important topic, at the same time very interesting and sets the fundamentals of the chapters yet to come. Okay, so if you talk about weightage of this particular topic in mains, we can expect two questions and at least one question will be there for sure. And in advance also, this topic is having very good amount of weightage. If you talk about JEE Advanced 2025, there were two questions from this particular chapter. One question was from the field due to electric dipole. Two dipoles were there and you need to find the field on the axial line and on the equatorial line. And there was another question that was from Gauss. And these questions were very straightforward, very fundamental. Just if you understand the key concept, you can quickly solve those questions. So in this video, I'm going to discuss all the key concepts that are must for JEE Mains. Okay, so all those key concepts I'll be explaining you and I'll be showing you the type of questions that are asked from these particular topic. And not only that, I have a good collection, hand-picked collection of the questions and from the topics which are expected to come in 2026, and that collection will be there for you in the description box. So when in the description box, when you click the link, you'll go to the app, join the free batch there, and in that batch you'll get the notes as well as the DPPs. PW platform is the most trusted platform where we provide high quality teaching at affordable prices, and so many students are taking advantage of it by scoring very good AIR. So make sure you go in the description box and join that batch in our app. So make sure after watching this video, you complete it in the comment, and as well you solve all the questions. So let us begin the discussion. First of all, these topics we'll be going to cover. Okay, we'll discuss about properties of charges, then Coulomb's law, then field and flux, Gauss law, electric dipole. I will be covering everything in this particular chapter. There are some few subtopics which I didn't mention there. Okay, so first of all, basic property of charges. You already know additivity of charges. If a body has, let us take plus 2q charge, minus q charge, plus 3q charge. If you need to find how much is the total charge that is there with the body, how much is that? 3 plus 2 minus 1. You'll say this total charge is 5q. So you'll just add it like a scalar. Charge is conserved. If I take an isolated system, the charge is not going to change. Quantization of charge, any charge is the integral multiple of 1.6 into 10 to the power minus 19. If it is a charge, if it is a negative charge, it will be multiple of minus 1.6 into 10 to the power minus 19. It means that body has excess of electrons. If it is a positive charge, it will be multiple of plus 1.6 into 10 to the power 19. It means that body has left few electrons. Okay, so I'll say the charge is quantized. You will not have a charge which is let us take 2 by 3 of charge of electron like that. That is not possible when we are talking about the static charges. Okay, so stable systems. Okay, so here I'll say any charge that is integral multiple of 1.6 into 10 to the power minus 19. Next is charge is invariant. It is independent of frame of reference. Charge is a scalar and transferable. How we can transfer charges? Okay, let us discuss this question first. We'll come to what are the ways of charging, how the charge can be transferred after this question. So a body has minus 160 microcoulomb of charge. Number of additional electrons in it will be. Now as we discussed, quantization of charge is there. So I'll say whatever charge is there here, Q, that is equals to Ne. Now this is a negative charge, so I'll write minus 160. This is microcoulomb. Micro 10 to the minus 6. Coulomb is the SI unit of charge, as you all know. Coulomb is the SI unit of charge. 1 coulomb is, I'll say, 1 ampere into the time. So if I say, let us take 1 coulomb. So 1 coulomb is basically equal to 1 ampere into the time, that is 1 second. So this is 1 coulomb. So this minus 1.6, this is minus 160 into 10 to the power minus 6 microcoulomb. This is equals to Ne. So number of electrons into charge of 1 electron, how much is that? Minus 1.6 into 10 to the power minus 19. Like this we need to write. From here we have to find N. So let us solve it. So this is minus sign is getting cancelled. 10 to the power 2 will be there. Okay. Now we have minus 4 and this is 10 to the power plus 19 when it will come here in the numerator. So it will become 10 to the power 19 minus 4, that is 15. And this is my n. Let us check the options. 10 into 10 to the power 14. Yeah, C is the correct match. Now methods of charging. First is friction by rubbing two bodies. Okay, so one get positively charged, another get negatively charged. That is clear to us. Next is induction. Induction means without any contact you are transferring charges. How? Let us take here we are having two spheres. They are initially kept in contact. I am bringing a negatively charged object near to the sphere. So what happened? The positive charge is attracted because you know that opposite charges attract each other. So positive charges are attracted here, these spheres are conducting. So positive charge will come here and negative charge will come here on the other side. Okay. Now I separate these two spheres. When I separate these two spheres, one is having only positive charge, another is having only negative charge. I'll remove this object, okay, which was initially negatively charged. I'll remove that object. Now one become positively charged, another become negatively charged. However, if you ask me, sir, is the charge conserved in this? Yes, the total charge of this system, that is conserved. Total will be 0. Whatever positive charge sphere A is having, the same negative charge sphere B is having. Okay, so this process of charging is induction. Now conduction means transferring charge. Let us take by using the process of conduction, like one object is charged, another, let us take one sphere, you are having one metallic sphere that is charged, another metallic sphere is uncharged. You are connecting them with a conducting wire. Okay, so the charge will be transferred, or you are bringing the two spheres in contact, so the charge will be transferred. Next is thermoionic emission. You are applying, let us take very high temperature to a metal surface. So what happens, the electrons are there, they are ejected after getting some energy, they will eject from the surface, the metal will become positive charge. So this is thermoionic emission. Next is photoelectric effect. Anyways, we are going to discuss this in our modern physics chapter. Okay, what happens in this? So high energy photons fall on the surface of the metal and the electrons gains that energy from the surface and they are ejected out. So what happens? The metal gets positively charged. Next is field emission. You apply very high electric field. Okay, you apply very high electric field such that the ions, or I'll say the electrons, they leave the surface and again the metal will get charged. So these are few of the ways of charging. Now we have a question on this. This question was asked in JEE 2007. Let us read it out. Consider a neutral conducting sphere. A positive point charge is placed outside the sphere. The net charge on the sphere is then. Okay, so this is a sphere. This is a neutral charge sphere. Now you are bringing a positively charged, okay, positive charge. Let us take plus Q. You kept here. So what will happen? You will say, sir, induction will happen. Due to induction here, negative charge will come. Here, positive charge will come. Because this positive charge will attract the negative charge. Okay, so positive charge will be on the other end, negative charge will be here. So now he is asking the net charge on the sphere is, net charge on the sphere is 0, isn't it? Because charge is conserved, net charge on the sphere will be 0. So the option is D. Now let us discuss about Coulomb's law. This is the law which tells about the force between two charged particles. So let us take two charged particles are there. They are separated by a distance r. Now the force between them is given as F is equals to 1 by 4 pi epsilon naught Q1, Q2, the charges are Q1 and Q2 divided by r square. I am considering they are kept in free space in vacuum. Now, one thing you need to understand, if the charges are opposite, they will attract each other. One is positive, another is negative, they will attract each other. The force will be equal and opposite. On this F it is, on this charge it is in this direction, on this charge it is in this direction. If both are positively charged, they will repel each other. And if both are negatively charged, they will also repel each other. Similar charge repel, opposite charges attract. That you understand? Now this is the magnitude of the force. Here I ask you, what is this 1 by 4 pi epsilon naught? This is a constant. What is this epsilon naught? This epsilon naught we call as permittivity of free space. Now what is this permittivity basically? Let me write first here. This is permittivity of free space. Okay. What is this permittivity basically? Like, you understand what is resistivity. What is resistivity? You will say resistivity is a property of metal which tells us how it is favorable for the transfer of the charges. Greater the resistivity, lesser it is favorable. Okay, lesser the resistivity, greater it is favorable. If the resistivity is very less, we will say these are conductors. Okay, they allow. If resistivity is very high, we will say these are insulators. They do not allow. Now, similarly, this permittivity tells us how much the greater the force will be if you see between the two charges. If this permittivity is greater, the force will be lesser in that medium. If you change the medium means which is having a medium which is having higher permittivity, so what will happen? This force will be lesser. Okay, if a medium which is having lesser permittivity, this force will be greater. Okay, so this permittivity depends on the medium, not the charges. It's a property of the medium. Okay. Now, what is this value of this 1 by 4 pi epsilon naught? You need to remember this. So, 1 by 4 pi epsilon naught is basically equal to 9 into 10 to the power 9. What are the units? Force is having unit of Newton. This R square will go on the other side, so Newton meter square. Q1, Q2 will come in the denominator, so per Coulomb square. So this is the SI unit of 1 by 4 pi epsilon naught. Okay. Now, if you ask me what is basically the unit of epsilon naught and what is its value. So from here, if you solve it, it will come out to be 8.85 into 10 to the power minus 12. Okay. And if I write the unit, it will be opposite of this. So it will become Coulomb square per Newton meter square. Many times the dimensions of epsilon naught are asked. Many times this is asked. Okay, so make sure you learn how to write the unit of epsilon naught. So this is how we write the unit of epsilon naught. Now you can convert this Coulomb in terms of ampere into second. Okay, Newton you can write as kg meter per second square. Okay, then other thing is meter square only, and then you can write the dimensions of this. So many times the dimensions are asked for epsilon naught. Okay, some expression will be given to you, let us take a mu naught by epsilon naught or like that, or sometimes only epsilon naught. So these dimensions are asked. So make sure you learn how to write its unit, from there how to write the dimensions. Okay, now let us learn how this is the magnitude, how to represent this in vector form, that we have to learn here. Okay, so let us take this is y-axis, this is x-axis, and we are having 2 point charges q1 and q2. Let us take the position vectors of these q1 and q2 are r1 and r2. Let us show that. So position vector of q1 is r1, and for q2 it is r2. Now, if I ask you that, can you tell me what is this vector? What is this vector? You know r1, you know r2. Can you write this in terms of r1 and r2? You'll say yes, we know the triangular law of vector addition. r1 plus this vector is equal to r2. Okay, r1 plus this vector, that is equal to r2. See the sides. Okay, this one vector, then this vector. Okay, then this resultant of these two is this r2 vector. So I can say this vector is basically r2 minus r1. And let us write it as r21. Okay, now if I show the forces, force on q2, that is in this direction, force on 2 due to 1, and force on q1, that will be in the opposite direction like this, F12. Now you will say, sir, how you can say the direction of force is like this? We do not know whether Q1 and Q2 is positive or negative. If they are negative, isn't the, like one is positive, another is negative, isn't the direction of the forces will change here? Wait, when I'll write this in vector form, if positive, negative signs are there, they will be taken care of. You know that in a vector, if I multiply that with -1, the direction become opposite, isn't it? So that will be taken care by that. Okay, so this, if I write now force on 2 due to 1, first of all, let us write the magnitude. How much is the magnitude? 1 by 4 pi epsilon naught. Now, this 1 by 4 pi epsilon naught, we write sometimes this as k. This we write as k, small k, okay, a constant. So, I'll say this is k q1 q2 divided by r, what is the distance? r12, the magnitude of that vector. So, r12 square. This is the magnitude. Now, we need to multiply that with direction. Direction means a unit vector. Unit vector means the vector divided by its magnitude. So, r21 divided by r21. Okay. So, this becomes q1 q2 r21 divided by r21 cube. Okay, and if you write f12, that is just the opposite. Okay, these two vectors are just opposite of each other. So I'll say f12 is minus of f21. That is clear to us. Now, is it needed? Do we need to write the force like this to find the resultant of the forces? If let us take multiple charges are there, no, need not. Okay, because if you go that way, so it will take a lot of time. We'll come to questions. So this is just such that you understand how we can represent that term in vector form. Okay, that's all from here. But when we have multiple charges, we will not write like this because it will take a lot of time, unnecessary. Okay, that is not needed. We will come to a question. Okay, we will come to such questions. Next thing, we discussed that epsilon naught is permittivity of free space. It means if the medium will change, this epsilon will change. This is only for free space. What if I ask you for water, or maybe let us take some other medium, permittivity will change, isn't it? Yes. So for any medium, if the dielectric constant is k, this capital K, okay, this is the dielectric constant of the medium, dielectric constant of medium, if K is the dielectric constant of medium, the permittivity of that particular medium, epsilon will write, that will become K times of epsilon naught. So in the questions, you will be given that there is a medium whose permittivity is, let us take 5 or 3 or 2, that what you need to do, the permittivity will becomes, so dielectric constant will be given, okay, 5, 3 or 2, whatever it is, so they will give you. So dielectric constant, you know, if now you need to write the permittivity, you will say it will become K times. It means the force will become 1 by K times here, isn't it? Yes, we will come to such question also. Let us discuss this question first. What it is asking here, in hydrogen-like system, the ratio of Coulombian force and gravitational force between an electron and proton is of the order. So we need to tell the order of the ratio of the two forces. So first of all, which force is greater? If I ask you which force is greater, certainly the Coulombian force is greater. Why so? Because in gravitational force, if you see the constant, we say in gravitational force the formula is G m1 m2 by r square. There G, what is the value of G? 6.67 into 10 to the power minus 11. Okay, that is minus 11. But if I ask you what is the formula for this here, okay, Coulombian force, so you will say, sir, that is K q1 q2 by r square. What is the value of K? 9 into 10 to the power 9, isn't it? So which one is greater? Here in the numerator there is 10 to the power 9, there in the numerator it is 10 to the power minus 11. So actually this electrostatic force or the Coulombian force is greater. Now let us find the magnitude. Okay, so if I say F electrostatic divided by F gravitational, I need to find this ratio. Write it. What is F electrostatic? K Q1 Q2 by R square. So I'll say K Q1 Q2 by R square divided by here G M1 M2 by R square. So anyways, the ratio will not depend on the distance. Now we'll put the value of charges of electron and proton, put the value of masses and the K and G, and then we'll solve. Let us do this. What is K? K is 9 into 10 to the power 9. What is charge of electron and charge of proton? Magnitude is the same, 1.6 into 10 to the power minus 19. So square of that will become here 1.6 into 10 to the power minus 19 square divided by G M1 M2. What is G? 6.67 into 10 to the power minus 11 into mass of electron is 9.1 into 10 to the power minus 31. 9.1 into 10 to the power minus 31 kg into mass of proton is 1.67 into 10 to the power minus 27 kg. These value you should remember because anyways many times these are required. Even in modern physics also many times the mass of the electron, the mass of the proton or their charges, these all things are required. So you should remember these values. Now what we need to find? We need to find the order. We need not find the exact value. Okay, we just have to find the order. How much 10 to the power will come? So I can approximately cancel few of the things. 9 I am cancelling with 9.1. 1.67 I will cancel with 1.6. It is square. So another 1.6 into nearly 4 it will become here. Nearly. Okay. So numerical values are cancelled. So 1 by 4. Now 10 to the powers are remaining. 10 to the power, this is 9. It is 19 into 2, 38. So minus 38. This is 10 to the power minus 11. In the numerator, it will become plus 11. Then minus 31, so it will become plus 31. Then minus 27, so plus 27. That's all. Okay. So 31 plus 7, so 2 will remain here, is equal to 38. That is getting cancelled. So this is 13 plus 27, this will become 40. So this is 10 to the power 40 by 4. So this will become nearly 2.5 into 10 to the power 39. The value will not be exactly 2.5, okay? It will vary because I have cancelled few things which are not exactly the same. 9.1 and 9, 1.67 with 1.6, 6.67 with 1.6 into 4. Okay, so this order we are getting as 10 to the power 39. Okay, simple, easy. Another question. Force between 2-point charges Q1 and Q2 placed in vacuum is F. Okay, the distance is R centimeter. Force between them when placed in a medium having dielectric constant 5 is at a distance R by 5 centimeter apart will be. Now the distance is changing, the dielectric constant is changing. So first of all, let me write what was the initial force. What was the initial force? So if I write F1, what was F1? So F1 will become K Q1 Q2 divided by R square. Okay, and let me write in terms of epsilon only. So 1 by 4 pi epsilon naught. Charges are Q1 Q2. So Q1 Q2 divided by R square. This was the magnitude of initial force between the two. Now F dash. Now here it is mentioned that the dielectric constant of the medium is 5. It means the permeability, not permeability, the permittivity will becomes 5 times. So epsilon will be 5 times of epsilon naught. Like this. Q1, Q2, they are the same. Distances becoming 1 by 5 square.
And if you see here, this is 1 by 5 square, 25 in the numerator, by 5 it will become 5. So it is 5 times of f. It is coming as 5 times of f, which is option B. So this is how you have to consider when the medium is changing. Here the medium is changing. Dielectric, another medium is there whose dielectric constant is given to us. So you need to consider the permeability to be dielectric constant times the initial permeability. Let us read this question. Two identical balls, each having mass m, charges q, suspended from a fixed point by threads of length L. What is the equilibrium separation when each thread makes a small angle theta with vertical? Now here basically you have to apply equilibrium. You have to show all the forces, okay, and there apply equilibrium, and there you can find the equilibrium separation between the two. So first of all, let us draw the shape, draw the free body diagram and other things. Let us draw the diagram, okay. So mass is m, charge is q, and thread length is L. With the vertical, the small angle is theta. Okay. Now if I draw here, let me draw a line first. So this is, let us take one ball with one of the threads, another thread here, and with the vertical they are making small angle, and this small angle is theta. This is one ball, mass m, charge q. This is another ball, mass m, charge q. And this, the separation between the two, let us take this as r. We have to find this separation between the two. Here, if I ask you how many forces are there on one of the ball, you will say, sir, force due to gravity is there. Yes. Force due to thread is there. Thread is there, so it will be also applying some force. Force between the two charges will also be there. So 3 forces, okay. Let us write that. One force, this force due to tension, let us take this as T. Another force, force due to gravity, mg. Another force, the electrostatic force, F electrostatic. And with the vertical here, if I ask you how much is this angle, again you'll say this is theta only. If this is theta, this is also theta. Now I'll take the component of this tension force T, horizontal and vertical, and then I'll apply equilibrium in horizontal direction and equilibrium in vertical direction. So let us do that. So if I take the components, what will be this component? This is T sine theta. What will be this component? T cos theta. Okay, T sine theta and T cos theta. Now here apply equilibrium one by one in horizontal and then in vertical direction. So in horizontal direction, if I write T sine theta is my F electrostatic. T sine theta is F electrostatic. What is F electrostatic? K Q1 Q2 by R square, I can write like that. So this is K. Both the charges are Q, so Q square. The separation I am considering as R, so R square. And this is my T sine theta. Another equilibrium if I apply in vertical direction, so T cos theta is mg. So T cos theta, this is mg. This is first equation, second equation here. Now here if you see, we don't need T. It is not asked, we are not interested in that. We will divide these two equations, tan theta will be there and R will come also there, and we need to find R. Also if you check in the options, the answer is not in terms of theta. So you need to replace tan theta also. Okay, if I divide it, so this will become tan theta and this is equal to kq square by mg r square. This theta is very small. If theta is very small, sine theta is nearly equal to tan theta, and that is nearly equal to theta. That you understand? So in this right angle triangle, if I ask you what is sine theta there, because sine theta we can write here. Sine theta, we know this distance is r by 2. This is L. So I can write sine theta from there. So if I write sine theta, that is perpendicular by hypotenuse, so r by 2 by L. So this is my tan theta, nearly, for theta is small. Now this tan theta I can put here, so this is r by 2L. From here I can simplify for r. So if I take r square on the other side, 2L on this side, so this will become r cube. This is equal to what? 2L kq square divided by mg. Okay, and our options are in terms of epsilon naught, so I'll put k as 1 by 4 pi epsilon naught. So this will become q square L by 2 pi epsilon naught mg, and if we have to write r, so that will become cube root of this. Okay, let us check the options. So q square L by 2 pi epsilon naught mg, yes, B option. Okay, whole to the power 1 by 3 is there. So this is power 1 by 2, here this is L square, here also this is L square, so not correct. B option is the correct answer. So these were I'll say some varieties here we saw. Okay, question was simple, but it was of multi-concept. Here we need to apply equilibrium also. So you need to show all the forces, take the component of the forces, apply equilibrium. Okay. Now let us talk about principle of superposition. Now this principle of superposition, many students are confused with this principle. This is very simple, nothing complicated. Principle of superposition says that if there are, let us take multiple charges, you need to find force on one of the charge. You find the forces due to each of the charge on that particular charge, take the resultant of all those forces, that will be your resultant force. Okay, this is how what we have to do. So what principle of superposition telling here? It is saying that force on one charge due to other charge is independent of presence of the other charges. So when you are writing, like I'll tell you, let us take multiple charges here. I am saying this is 1, 2, 3, 4. Okay, let us take this is q1, this is q2, this is q3, this is q4, and there is another charge q here on which you have to find force. So I am saying one by one you find all the forces due to q1 first, then due to q2, then due to q3, due to q4, take the resultant of that. Okay, so superposition is saying when you are writing force due to q1, don't see for q3, q4 or q2, means force due to q1 is independent of the presence of these, that will not depend on the presence of q2, q3 or q4. Okay, so let me write it. So due to q1, when you will write just force is equal to k q1 into q divided by separation, let us take this is r1, so r1 square. You will not see q3, q4, q2 while writing this. Okay, independent of the presence of these. When you are write due to q2, don't think about other three. Write due to q2, this is force due to q2, let us take this is f2, this was f1. Due to q3, let us take this is f3. Due to q4, this is, let us take f4. Now what is the total force? Take the resultant of the 4. F1, F2, F3, F4, you have to take the vector resultant, not just add the magnitude, no. So if I write the total force, so F net, that is F1 plus F2 plus F3 plus F4. Now one thing is, either you take the x component and y component and write all the four forces in I cap, j cap, and then add all the I caps together, add all the j caps together. That way you can find the resultant. Or you can take the components and there itself you can cancel some of the component and write the resultant. That is one of the way. Any of the methods that is easier for you, you can apply. I'll show you how to do this. One of the questions here. Two electrons each are fixed at a distance 2d. A third charge, proton, placed at midpoint is displaced slightly by distance perpendicular to the line joining the two fixed charges. Okay, proton executes simple harmonic motion having angular frequency. What is the frequency? So this question is a mixture of oscillations as well as the concepts of electrostats here, just the Coulombic force. Okay, so it's a mixture of that. You need to know how to find the time period, or not time period, just the frequency. So how we basically do, what we do to find the time period, what we do is, let us take initial, the proton is there in the equilibrium. What I will do, I'll displace it by distance x and I'll see how much is the force now. Whatever is the force, okay, that becomes my restoring force. That restoring force I'll equate with mass into acceleration. From there I'll find the acceleration. Acceleration is equals to omega square x for simple harmonic motion. Negative sign is also there. Okay, from there I'll find omega, because force will be in terms of kx, so anyways that x is getting cancelled. From there we'll find omega, and if we have to find time period is 2 pi by omega. Simple, straightforward, easy. So let us do this here. Let me show you how the charges are placed here. First, okay, so two electrons here and here. The separation between the two is given as how much? 2d. Proton is somewhat here at a distance x. This is distance x and this is very small. I am showing it a bigger so that you can visualize this. This x distance is very small as compared to d. Now when I am displacing this proton by some distance, this will have a force due to this electron. Let us take this as f. It will have a force due to that electron. Let us take that as f. The resultant of these two will be in the downward direction, okay, because the horizontal components will get cancelled out, the vertical component will add up. So if I say this angle is theta, so this angle is also theta, and 2f cos theta will be in this direction. This is my restoring force basically here. Okay, here the charges are given as, what is the charge? Here it is not mentioned what is the charge, but in the options it is given as q. So it means q is charge of electron and proton. So if I write this, my restoring force, what is that? 2f cos theta. What is f? F is k into q1 q2 divided by the distance square. What is this distance? This one. So this distance I'll say that is this is d, half of this is d, this is x, this is a right angle triangle, so hypotenuse is root of d square plus x square. I'll put it here. So k q1 q2, so q square divided by the distance square, so d square plus x square, okay, that is clear to us, into cos theta. What is cos theta from here? Cos theta is x by hypotenuse again, so that is x divided by d square plus x square whole to the power 1 by 2, because distance is root of this. Okay, so this becomes my restoring force now, and if I write it, so this will become 2kq square divided by d square plus x square to the power 3 by 2, and x is also there in the numerator. This is right. One thing is given here that this x is very small. If this x is very small, I will neglect x square in front of d square because d is very big in compared to x. So d square will be further more big as compared to x square. So this I can neglect here. If I neglect it, this will become 2kq square x divided by d cube, isn't it? Now this is my force and I'll write this as mass into acceleration. Okay, and for simple harmonic motion I'll write acceleration as omega square x. Minus sign would be there, one minus sign here, and this is also negative. Why so? Displacement is in the upward direction, force is in the downward direction. So understood it is that it's a negative sign is also there. So negative is cancelling. I'm not writing sign here. I'm just writing the magnitude of restoring force. Now from here this x, oh I did a mistake. Yeah. From here this x is getting cancelled and I can write omega square as 2k q square by m into d cube. Okay, everything perfect? Yes. Now the answer is in terms of epsilon naught, so I'll put k as 1 by 4 pi epsilon naught. So omega will become root of q square by 2 pi epsilon naught m d cube. Q square by 2 pi epsilon naught m d cube. Coming to the options, q square by 2 pi epsilon naught m d cube. C matches with our answer. So it was a multi-concept question, requires concept of oscillation and this particular chapter. Okay. Also superposition principle we used here. Try to understand, we use superposition principle. How? When we were finding force on this proton, we took the resultant of force due to each of the electron. This electron F, this electron F, resultant of these, that is 2f cos theta. So that was principle of superposition that we used here. Another question now. Read it out. Equal charges Q are placed at 4 corners ABCD of a square. The magnitude of force on the charge P will be. Okay. So this is I'll say a simple question which like we use principle of superposition only. 4 charges are there and on any one of them we have to find the force. It is placed symmetrically. So any one of them I can find the force is same. Okay. Let us do that. So let me select a square. 4 charges are there. Q, here also Q, here also Q, here also Q. Let us take this is A, this is B, this corner is C and this corner is D. Now, if I find force, let us take on B. First of all, I'll write due to A. What is that? That will be in this direction. How much is that? K, Q1, Q2 divided by side is A, so A square. So K, Q square by A square. That is clear. Due to C, if I write, that will be in the upward direction. How much is that? The same magnitude. So that is also K, Q square by A square. Okay. Now due to this D charge, the force will be along the diagonal. So along the diagonal, that is this. How much is that? K, Q square divided by, the distance is A root 2 here. So A root 2 square will become 2A square. Now I have to take the vector resultant of these 3 vectors. Now one thing is, either you write that in terms of I cap J cap form, Okay, but we need to just find the magnitude. Need not here the direction he is not asking, and it is just straightforward. Why? You see, these two vectors are equal in magnitude. The angle is 90 degree between the two. The resultant of these two will be along the diagonal, and one vector is along the diagonal, so just add that with this, so that will be the resultant. Okay, so if you take the component of these two along the diagonal, they will add, perpendicular to that they will cancel each other. So just add the component along the diagonal plus this that is already along the diagonal. How much is that now? So it will become k q square by a square cos 45, because this angle is 45 degree. Okay, similarly due to this also I will say, so into 2 plus this is already along diagonal, kq square by 2a square. Now this is the resultant force. So if I write it, it will become kq square by a square, I am taking as common out, root 2 plus 1 by 2. Let us check the options. Root 2 plus 1 by 2, if I write, it will become 2 root 2 plus 1 by 2. Okay, kq square by a square 2 root 2, 1 plus 2 root 2 by 2. Is there any mistake I did? No. Let me again check. Yeah, everything is fine. This was root 2 here in the denominator. This is 2. We need 2. So C is coming out to be the correct answer here. Okay. So you learned how to apply principle of superposition. Now let us talk about electric field. What is basically field? If I ask you, two charges are there, Q1 and Q2. How Q1 is applying force on Q2? There is no rope, there is no contact between Q1 and Q2. Still, how Q1 is able to apply force on Q2? We will say that there is field. There is field. So the field of Q1 is there. That field is applying force on Q2. Similarly, field of Q2 is there. That is applying force on Q1. So in between, the field is there. That electric field of Q1 is applying force on Q2. Electric field of Q2 is applying force on Q1. Okay, so here comes the concept of electric field. Now, how we define electric field? Let us take, this is a charge Q. Okay, now I have to find electric field of this charge at a particular point, this point P, and the distance is R. How much is the field? So what I will do, I will bring a test charge, place this test charge here. Let us take this test charge as Q naught. I will find the force on this test charge, that is in this direction F. So if I write F, so you will say this F is K Q naught by R square. Okay, so this field is defined as force per unit test charge. So divide this with this test charge Q naught. So you will get electric field as, or just the magnitude here I am writing, K Q by R square. So why this test charge is very small? One thing is, okay, we consider this test charge to be very small such that this Q will remain fixed. Okay, it will not have any force. So if the force is there, distance will change. So therefore I am considering this Q naught to be very, very small. Okay, and we got this force per unit test charge, that becomes KQ by R square. Now here if I ask you what is the unit of E, you will say, sir, this is unit of force divided by unit of charge. So if you write the unit of electric field, what it will become? That will become Newton per Coulomb. or one more is there that we write as volt per meter. How that is volt per meter, we'll come to know after some time. In the next chapter, we'll discuss about potential and other. So E is minus dV by dr. So from there we got unit as volt per meter, or even you can express Newton in terms of kg meter and second, and that way also you can write it. Okay, so due to any point now, any point charge, if you have to write the electric field at a certain distance x, a certain distance r, you will say that is kq divided by r square. So you should remember this formula, kq divided by r square, due to one point charge at any point. Okay, now if there are multiple charges and you have to find force, or I'll say field at one point, how will you find that? Again, using the superposition principle, find electric field due to each of the charges, take the vector resultant, that will become the net electric field at that particular point. So if I say there are charges q1, and let me write as small q, so q1, q2, q3, q4, like that. Okay, so this is principle of superposition. Let me write. Now the way here we defined, where it is, yeah, the way here we defined principle of superposition, here we were finding forces. Okay, the same way here we are defining, here we are finding electric field. So at a particular point, now if I have to write electric field, I'll write due to q1, let us take this is E1, write due to q2, that is E2, write due to q3, let us take that is E3, due to q4, E4. Okay, so one more thing, if the charge is positive, the electric field line, the field we show is away from the charge. Okay, if it is negative, it is towards the charge. Okay, so I'm considering q1, q2 as q3, q4 as positive, therefore I showed this direction. Also, if any one of them will be negative, the vector will automatically become opposite, so need not worry about that. So when you write the net electric field, you will take the resultant of the vectors E1, E2, E3 and E4. You will take the resultant of these four vectors and that will become the resultant electric field at that particular point. Coming to the questions. Three charges q by 2, q and q by 2 are placed at corners A, B and C of a square of side A as shown in figure. The magnitude of electric field at corner D is, okay, so this I think this should be C and this corner is D. Yeah, three charges are there, we need to find. Now previously there were four charges, we have to find force on one of them. Now here three charges are there, we have to find electric field at one of the point. Let us write it here. This is the square and three charges. What is that? Q by 2, q and q by 2. So this is q by 2, this is q and this is q by 2. The side is, what is the side is A? Is that? Yeah, the side is A. Need to find the force, need to find the field. Okay, here we have to find the field. So due to each of the charges I'll write, due to this q2, the field will be in this direction. How much is that? KQ by R square. So K Q by 2 by the distance square A square. Similarly, due to this Q by 2, field will be in this direction, K Q by 2 by the distance square. Now due to this Q, it will be along the diagonal. How much is that? K Q divided by the distance square. Distance is A root 2. A root 2 square is 2A. Now how to take the resultant of these three vectors? These two are equal at 90 degree. The components along the diagonal will add, perpendicular to the diagonal will cancel. Okay. Now take the component along the diagonal and add that with the component that is one of the vector that is already along the diagonal. Okay. This angle is 45 degree. So if I take the component, so that is K Q by 2 by A square cos 45. Here also if I take, it will become the same, so into 2 plus this, that is this was square here, so that is KQ by 2A square. Okay, this is how you have to write. Now I can put the value of cos 45, that is 1 by root 2, so this will become KQ by A square. This I am taking as out common, so this will become 1 by 2 root 2. This is 1 by 2. Okay, this 2 is also there, so that will anyways get cancelled. So this will become 1 by root 2 plus 1 by 2. So this is the expression that we are getting. Let us check it out. So 1 by 2 plus 1 by root 2. Okay, K is 1 by 4 pi epsilon naught. Option A is coming out to be correct here. Now many of you, those who have already done these fundamental questions might be feeling, sir, these are basic questions, we already know these things. Okay, move further. And many of you, those who have not solved these type of questions or not familiar with these type of questions, they are understanding the concept. But the point is, these simple questions are asked in JEE mains. That is the point. These simple questions are asked in JEE mains. This is 2022. There is nothing complicated that is asked. Only thing is, in the simple things only we do mistake. So although I am taking those simple questions also which are asked, and these type of questions are going to be asked, nothing from outside of the world, no. Like in JEE Advanced 2025, this year, this particular year, if we see the paper, there was one question from electric dipole. There you need to find the electric field due to the dipoles. Such simple question. You may say, sir, we know the formula how to find the electric field on the axial line, on the equatorial line. Yes, you know, that's only you had to apply there. The thing is, the questions that are asked that are not complicated. But the thing is, by seeing them fundamentals, by seeing them basics, we avoid them, and the same things are asked, and when we solve in the exam, what happens? We do a mistake. Although that thing was very simple, but we do a mistake in solving that. So this is the problem. So even when I am solving here, so you might be like watching the video, some of you may be watching this at 2x. So even if you are watching at 2x or 1.5x, you should have a notebook with you. Try to solve these questions, and after this class you will get the DPP also. Okay, so these notes will be there, need not write everything, okay, in the notebook, so don't make the notes. You'll get these notes and the DPPs in the description box. So in the description box below there is a link, you'll click that link, you'll go to our app, okay, that is PW app. So many of you are already familiar that many of the students are taking advantage of PW app. So there you'll join our this free batch, and there itself you will get the DPPs, the practice questions and the notes. So the DPPs are important because these DPPs are selected questions which are expected to come. So make sure you download the DPPs and solve these DPPs after the class. Okay, coming. Two charges Q and 3Q are separated by a distance r in air. Okay, at a distance x from charge q, the resultant electric field is 0, the value of x is. Resultant electric field is 0 means what? Make the resultant of the vectors to be 0. Find the individual electric field due to each of the charges. Make the resultant of the vectors to be 0. Simple. So, two charges he is saying q and 3q. So, I will show it. Okay. I will show. Let us take this is q and this is 3q. Separated by distance r like this. At a distance x from charge q, here the resultant field is 0. Now, you see, when I was reading the questions, I was drawing the diagram. So, this is what you have to do. In the exam, sometimes like a question is sometimes a bit lengthy. In mains, the questions are not that much lengthy, but sometimes it happens that few of the questions are lengthy. Okay. So, what happens? You are reading the whole question. Okay. So many things were given, and then when you come at the end, then again you have to see what it was there. So, what happens is like the time is wasted. So, what you need to do when you are reading the question, draw. The diagram will be there, some forces you need to show. So, that time only you can draw parallelly. Now, due to this q, field is in this direction. Let us take this as E1. Due to this 3q, the field is in the opposite direction, E2. For the field to be 0, E1 is equal to E2, then only the two vectors will cancel. So, what is E1? K q divided by x square. What is E2? K 3q divided by the distances r minus x. So, r minus x square. E1 is equals to E2, equate them. So, kq divided by x square is equals to k 3q divided by r minus x whole square. K is getting cancelled, q is getting cancelled, and from here r minus x square whole, it will come here, x square will go on the other side, it will take the root. So, r minus x is basically root of 3x, and from here I can write x as r divided by root 3 plus 1. Okay, r divided by root 3 plus 1. C option. One thing is, why I considered this x between the two charges? It's not mentioned that the electric field is 0 in between. Why not on one of the side? Because we know if I consider this point on this side, both the electric field vectors are adding, they will not cancel. If I take the point on other side, there also both the electric field vectors are adding, not cancelling. In between only they will cancel each other, therefore I took in between. Okay. Anyways, two of the options you can directly cancel. A option, you see, this is 1 by r. Distance is there, r will be in the numerator, not in denominator. A is incorrect. If you see the option D, the distance is greater than r, 1 plus root 3 times of r. So, D is also incorrect. B and C, two options are there. Anyways, solving this is simple, I am just telling you. Now, electric field intensity due to continuous distribution of charges. Due to point charge, we learned how to find the electric field at a particular point. That is clear. What is that? Kq by r square. Then we learned if there are multiple charges, write the electric field due to each of the charges, take the vector resultant, that becomes the resultant field. Now the third thing, what if there is a continuous distribution? Example is here, this is a rod which is uniformly charged and we have to find electric field at this particular point. So what we will do? You will say, sir, we will take one of the charge here. Due to this charge, I will find the electric field. Then due to other charge there, find the electric field. Due to other charge there, find the electric field. And that way I will cover the rod and take the resultant of these all electric fields to find the electric field. Yes, that is, you are continuously summing up the individual electric field. Continuous summation means integration. It means you have to integrate. How to integrate? What I will do is, let us take at a distance x from here, small section having thickness dx I'll consider. Due to this small section of the rod, here electric field is dE. I'll write dE, we'll integrate dE to find the total electric field there, E. Okay, so let us write dE. kq by r square, electric field is kq by r square. This is a point charge, very small. Let us take charge of this section, dx is dq. This charge, I am saying this charge as dq. Okay, total charge is capital Q, so I can consider this as d of small q, like this, capital Q, like this, dq charge. So I will say d is k dq divided by the separation x square. Now what is dq? This is uniformly charged. If this is uniformly charged, dq is charge per unit length, so total charge by total length into the length of this section dx. Try to understand this. The charge may be linearly distributed. There we take charge per unit length. Charge may be distributed in the area. There we consider charge per unit area. The charge can be distributed in the volume. There we considered charge per unit volume, charge density. Okay, this is how we define. So linear charge density, charge per unit length. Then surface charge density, sigma, we denote that with sigma. So that is charge per unit area. Then there is rho, that is charge per unit volume. All these three things we used according to the distribution. This is linear distribution. So here charge per unit length, that is q by L, into the length becomes my charge dq. Putting it dq, so k q by L dx by x square, now integrated. This is my dE, now integrated. Q by L is constant, so I am taking that out. Electric field 0 to E total. My x goes from, now this distance x, it was starting from this point going till here. So x goes from R to R plus L. So it goes from R to R plus L. This is what you have to integrate. Now integration, you already learned that just using the integration of 1 by x dx, what is that? Minus 1 by x. So kq by L minus 1 by x, limit from R to R plus L, and this is my E. So what it become here, k q by L into upper limit minus lower limit, minus sign is there, I will consider it, so it will become lower limit minus upper limit. Okay, got it? Do you need to remember this formula? No, don't remember this formula. This was just to make you understand, and if this question is asked, you can quickly derive it. There is nothing complicated in this. Now next, here we are having a uniformly charged arc, and the charge per unit length of the arc is given to us. Let me write the heading here. And what is this? This is uniformly charged arc. Uniformly charged arc. Okay, charge per unit length, lambda is given to us. This lambda is known to us. This angle is known to us. The radius is known to us. We need to find electric field at O. Again doing the same thing. We'll take small section there. Due to that small section, we'll see what is the electric field at O. Integrate to find the total electric field. So from, I'll say, let me make a line. So from O at some angle theta, I am taking a small arc making an angle d theta I'm taking a small arc. That small arc, this is making a small angle d theta there. Okay, this is d theta. This small arc will behave like a point charge. Due to this small arc, the electric field here, this is dE. How much is this angle? This is same as this theta. Don't say why you are not writing theta plus d theta or like that. This d theta is very small. Okay, d theta is very, very small. So this angle is theta. Now, I have to write dE first and then we will integrate that to find the total electric field. First of all, let me write dE. You will say dE is k into dq divided by r square. dq is the charge of this arc. Okay, so k into dq divided by the distance, that is equal to radius here, so by r square. Now basically, first of all, we need to write dq. Charge per unit length is given to us lambda here. So dq I can say charge per unit length into the length, same thing. So dq is charge per unit length. How much is that? Lambda into the length. How much is this length? R d theta. Length of arc is radius into the angle. Radius into the angle subtended by the arc. How much angle this small arc is subtending? D theta. So this length will become R d theta. R d theta, putting here lambda is also there. This is my dE. Now, this dE will have horizontal component also, vertical component also. Okay. Now, if I write the components, horizontal component is dE cos theta, vertical is dE sin theta. Now, if you see, if I integrate d cos theta, the resultant will come in that direction. If I integrate d sin theta, that will become 0. Why so? Because similar arc will be on the other side, that will be having dE sin theta component in the upward direction, and that will get cancelled anyways. So even if you integrate, you will get that 0. So the net resultant electric field, from symmetricity also we can say the net electric field is along the horizontal direction. So just integrate dE cos theta. So electric field will be in the horizontal direction only. So if I write E, so that is, okay, let me write E, that is just integration of the horizontal component Ex. Okay, so Ex is here, cos theta will also come. So dE into cos theta. So k lambda, 1 r will get cancelled by r into cos theta d theta. What is the limit? Here if you see, I am taking theta positive in the upper side. So on the lower side if I move, theta will be negative. So theta changes from minus alpha by 2 to plus alpha by 2. Okay, both are equal. This is alpha by 2 and this is also alpha by 2. So theta goes from minus alpha by 2 to plus alpha by 2. Cos theta integration is sin theta to k lambda by r sin alpha by 2. Okay, everything is right here? Yes. This is electric field, a formula of electric field due to an arc. Do we need to remember this formula? If it is possible, you can remember it. Okay. If it is not possible, so at least understand how to derive it. Okay. And if this alpha become pi by 2, means if alpha become pi, if alpha become pi, then it will become a semicircular ring. So due to semicircular ring, the field is 2k lambda by r. That you should remember. Due to semicircular ring, it will become 2k lambda by r. Okay. Yeah. Now next, here we have to find electric field due to a uniformly charged ring on its axis. Let me write it. Due to uniformly charged ring on its axis. Here also doing the same thing, one small point we will consider on the ring that will behave like a point charge. Due to that, I'll write dE, I'll integrate dE to find the total electric field. Again the same thing, just see it quickly. I'm taking one point here, that point is having, let us take charge dq. Due to this, if I write the electric field, that is dE in this direction, and that dE is k dq by r square. I have to integrate it to find the total electric field. dE, if this angle is theta, this angle theta, we need to take the components of dE. Okay, let us take the horizontal component. If I write, what it will become, dE cos theta, dE cos theta. What vertical it will become, dE sin theta. So this is dE sin theta. Okay, dE cos theta and dE sin theta. Now again the same thing, if you will integrate dE sin theta, it will come 0. You can visualize this also. How? If I take similar point on the other side of the ring, it will have the component somewhat like this. The horizontal is adding, the vertical is getting cancelled. So anyways, even if you integrate d sin theta, that will come out to be 0. Just integrate d cos theta. So the total electric field is coming out to be in the horizontal direction. Okay, E, that is just integration of dEx, I'll say, the horizontal component. So what is that? K dq by r square into cos theta. Okay. Now is this theta constant or variable? Means, is this theta changing or it is fixed? It is not changing, it is fixed. Theta is constant in this case. K is constant, r square is constant. You can take all that outside. So this will become k cos theta divided by r square integration dq. Integration of dq is q, total charge. Just write it. K cos theta by r square into q. Or if I write cos theta is base upon hypotenuse. Hypotenuse is r, that is root of x square plus r square. So this will become kqx. Oh, I did a mistake there. What is this? This was small r actually. Yeah. When I was writing due to dq, k dq by r square. R square was this small r distance actually. I wrote capital R there. This was not capital R, this was small r. Okay. Small r, again I wrote capital. This was whole small r square. Correct it. You got it? Why I am writing this small r? Because this distance when we have to consider, this is small r, not capital R, that is small r. Okay. So k q cos theta divided by r square, and then I am writing x. It comes out to be like this. And what is this? This is my small r, that is root of r square plus x square. So when you will write it, it will become k q x divided by r square plus x square whole to the power 3 by 2. Do we need to remember this formula? Yes, this is very important. Questions are asked based on this formula. So this is very important. And you can find also where the electric field become maximum. If you see at the center of the ring, electric field will become 0. As you are moving away at infinity, distance becomes very large, electric field is 0. So at somewhat in between, the electric field will be maximum, and that distance is r by root 2. So at r by root 2, you can differentiate it equal to 0, okay, you will get x is equal to r by root 2. So at r by root 2, the electric field is maximum, and at infinity it is 0, at center it is 0. Same on the other side. Now, uniformly charged disk. How to do this? We'll consider disk to be made up of so many rings, infinite number of rings. Due to ring, we know the formula, right? Due to one of the rings, integrate it to find the total electric field there. Let us see. So this is due to uniformly charged disk on its axis. I am considering disk to be made up of so many rings. This is my disk. So I am considering it to be made up of infinite number of these continuous rings. Due to any one of the ring, the charge is dq. Let us take off this ring. Due to one of the rings, I'll know here electric field is dE. How to write dE? We know the formula kqx. Due to ring, I'm using k into q. Charge of ring is here dq. So k dq into x, the distance, divided by here this small r. So r square plus x square to the power 3 by 2. This becomes my dE. Now I have to integrate it. R goes from 0 to capital R for complete disk, okay? Now, what is dq? dq is charge of this ring. Charge of this ring. How much is the charge of this ring? So dq is charge per unit area into the area of this ring. What is charge per unit area? That is sigma. So sigma into the area of this ring. How much is the area? That is 2 pi r, that becomes the circumference, into thickness of this ring, that is dr. So 2 pi r into dr, that becomes the area of this ring. So 2 pi r into dr. Now you can just to visualize, you can just flatten this ring into a straight strip, and that strip is having thickness dr. The length of the strip is equal to the circumference of this, that is 2 pi r into dr. That becomes the area of that rectangle strip. Okay, therefore 2 pi r dr. Okay, putting it there and then integrating it, and if you integrate it, you'll get this expression. Do we need to remember it? Yes, you need to remember it. It is asked. Not frequently, not very frequently as ring. Okay, ring formula is frequently asked, but yes, this is also asked. Now, this is electric field due to a uniformly charged wire. Now, one more thing in case of disk I need to tell you. What if the radius becomes infinite, means very large? What will happen? This will become a uniformly charged infinite sheet, okay, very big, uniformly charged infinite sheet, and this r is very big, so this will become 0. Electric field becomes sigma by 2 epsilon naught. So remember this formula now, field due to uniformly charged infinite sheet, okay. So field due to uniformly charged infinite heat, what that will become? R will become infinity, sigma by 2 epsilon naught. Okay, remember it here, my r become infinity. This is a important formula that you need to remember. Okay, you need to remember it. Sigma by 2 epsilon naught. Anyways, we'll come back to this when we'll discuss Gauss law. There also I'll show you how this sigma by 2 epsilon naught is coming by different method. Now next shape we are considering is uniformly charged wire. This is, or you may consider a rope, okay, that is uniformly charged. Some length is there and you have to find electric field at a point. The perpendicular distance is given to you x. The angles of the two ends of the wire is given alpha and beta, and you have to write the total electric field at that particular point. Okay, so let me write first. Due to uniformly charged wire, okay, what we will do, again the same thing, we'll consider one point on this wire. Due to that, write the electric field there, dE, okay, then integrate to find the total electric field. So that particular point I am taking here, let us take this small section. This small section is having length dE. Due to this small section, the electric field is dE here. This length is dl, okay. Due to this small section, the electric field is dE there. Now I'll take the horizontal component and vertical component. So horizontal component, that will become dEx. Vertical component will become dEy. We'll integrate dEx and dEy to find the horizontal and vertical components of electric fields there. Here alpha and beta are not same. If alpha and beta are same, only horizontal electric field will be there, vertical will cancel out from symmetricity, we can say. So but alpha and beta are not same, so in horizontal direction also there will be electric field, in vertical direction also there will be electric field. Now first of all, let us write what is dE there. So dE is k into dq. What is dq? Charge per unit length is not given, we'll consider that as lambda. So k into dq is lambda into dl, lambda into dl, okay. I can write here, dq is lambda into dl. So k into q, that is dq, divided by r square, the distance. This is my dE. Now if I write the horizontal component, that is dEx, okay. So first of all, let us relate dl, r and theta. Let us simplify, because here my theta is varying from alpha to beta, so I want to integrate. Theta is varying from, you can say, this angle alpha to another, the angle beta on the other side, not directly just alpha to beta. I will show you how to write the limits basically at the end. But here my theta is varying, so I want to integrate in terms of theta. So I need to replace dl and other things in terms of theta. So in this right angle triangle, if you see in this right angle triangle here, angle alpha, okay, this angle theta is there, not alpha, this is theta. So if I write tan theta, what is tan theta? Perpendicular by base, L by x. Simple. X is a constant, L is variable. If I differentiate both sides, so it will become secant square theta d theta is equals to dl, and x let me take on this side. This is clear to us? Yes. And if I relate r, what is r? R is x by cos theta, x by cos theta, so x secant theta. Write it here. So k lambda into dl is x secant square theta d theta, x secant square theta d theta divided by that is dl divided by x secant theta square. So you see here the secant square theta is getting cancelled. This is getting cancelled. One x will get cancelled. So x will remain in the denominator, and my final expression for dE, that comes out to be k lambda by x into d theta. This is what my final expression for dE coming. Now I'll write dex, that is dE cos theta. Okay, what is dex? dE cos theta. Vertical dEy, that is dE sin theta. Separately integrate. Okay, so let us find Ex first. So Ex is integration of dex. What is dE? K lambda by x into d theta. So dE into cos theta. Cos theta is also there. So cos theta d theta. This is my dex. K lambda by x cos theta d theta. What is the limit of theta now? Here you see, I am considering this side as positive. So my theta changes from, on the other side it will be negative. Okay, so minus beta 2 plus alpha. My theta is changing from minus beta 2 plus alpha. Try to understand this limit properly, because if you do mistake with the limit, entire integration will be wrong. Theta is changing from downward side, I am taking positive. So on the upward side if I go, that is negative. Minus beta, the upper end, to alpha, the lower end. Write it here. K lambda by x is a constant, x is not changing. Cos theta integration is sin theta minus beta to alpha. So this will become K lambda by x sin alpha plus sin beta. This is Ex. Similarly, when I'll write Ey, that will become K lambda by x sin theta d theta integration. So K lambda by x sin theta integration will be minus cos theta, limit same, minus beta to alpha. So this will become K lambda by x into cos of alpha minus cos of beta. So considering the negative sign, this will become cos of beta minus cos of alpha. This is my Ey. Everything is correct here. Let me see. Yes, this is perfect. Okay, so we got the horizontal component, we got the vertical component. If alpha becomes equal to beta, this Ey is getting 0. Symmetricity also says if alpha is beta, Ey will be 0. Only the horizontal component will remain there. Now, do we need to remember this formula? Well, if you can remember, I'll say you can remember this formula. But if you cannot remember, because sometime it is asked, sometime it may be asked. Okay, not in mains, then maybe in advance it may be asked. Okay, so therefore I want, if it is possible for you to remember this expression, good. If it is not possible, then I'll tell what you need to remember, what you must remember. That is the thing. So what you cannot, skip. What is that? So that, listen now. Based on this expression, I am saying, if I write field due to infinite wire, if I take infinite wire means like this, both the angles, if you take, they will tend to 90, this will also tend to 90, this will also tend to 90. So sin alpha and sin beta both will tend to 90. So due to infinite wire, only Ex will be there, Ey will become 0. And what it will become? Sin alpha is equal to sin beta. Okay, and both are 1. Okay, so that will become 2. So 2k lambda by r. This formula you must remember, and we'll come back to this formula when we'll discuss Gauss law. We'll come back to this formula again. If the wire is semi-infinite, this was for infinite. If I write due to semi-infinite, what it is, the wire is, let us take like this. Here you have to write the electric field. So when you write the horizontal, one angle is 0, another angle is 90 degree. When you write the horizontal, it is k lambda by r. Just write the vertical, it will also be k lambda by r. So k lambda by r in the horizontal direction, k lambda by r in the vertical direction due to semi-infinite wire. At least these formula you must remember. If you cannot remember that little longer expression of Ex and Ey, this you must remember. This is this you cannot skip. Okay. Now coming to a question based on this, let us read it out. A thin infinite sheet charge and an infinite line charge of respective charge densities plus sigma and plus lambda are placed at 5 meter distance from each other. Points P and Q are 3 by pi meter and 4 by pi meter perpendicular distance from the line towards the sheet. EP, EQ are magnitudes of electric field densities at point P and Q. We have to, if EP and EQ is given to us, we have to find here A. Okay, let me draw a diagram so that you understand it. We are having one infinite sheet, another infinite line charge. Okay, let us take one is infinite sheet, another is infinite line charge. Both I am drawing the same way. Let me make a bit more space. Let us take, this is my sheet and this is my line charge. Here the electric field is plus sigma and here it is plus lambda. 2 points P and Q. P, that is at a distance 3 by pi, okay, perpendicular to line charge. This is 3 by pi. Another point Q, that is at 4 by pi. 4 by pi. Now we have to write electric field at these 2 points. So now again superposition will be using. We will be writing the electric field due to sheet at that particular point, again due to line at that particular point, taking the resultant of the two to write, like again the superposition principle, isn't it? Individually write the electric field, take the vector resultant, that becomes the resultant electric field. Okay. So at P, if I write, let me use another color. At P, if I write due to sheet, due to sheet we know the formula sigma by 2 epsilon naught, that is independent of the distance. Okay, need not see what is the distance, because that is constant, sigma by 2 epsilon naught. So due to sheet at P, the electric field here is sigma by 2 epsilon naught. Due to this wire, direction is clear because this is positively charged, so field away. This is also positively charged, so due to line also it will be away on the other side. So due to line charge, if I write, what is that? 2k lambda by r. So 2k lambda by r is 3 by pi. Now same, write at q also. So due to this, sheet sigma by 2 epsilon naught. due to wire 2k lambda by r. Okay, we have written it properly. Now, let me write EP and EQ here. If I write EP from there, it will become sigma by 2 epsilon naught minus 2k lambda by 3 by pi. Here, it is given to us that 2 sigma is equals to lambda. So, lambda is 2 sigma, so I will put lambda as twice of sigma. So, sigma by 2 epsilon naught minus 2 into k I will put as 1 by 4 pi epsilon naught. Lambda is 2 sigma, this is 3 by pi into 4 pi epsilon naught. That is clear. Pi will cancel, 4 will cancel, sigma by 2 epsilon naught minus sigma by 3 epsilon naught, that is sigma by 6 epsilon naught. That is EP. Now let us write EQ. Again, sigma by 2 epsilon naught minus this, that is 2k lambda by 4 by pi. Again, lambda is 2 sigma, so it will become 4 sigma in the numerator, 4 sigma divided by k is 1 by 4 pi epsilon naught. So 4 into 4 pi epsilon naught by pi. Okay. Yeah, this is right. 4 by pi, k as 1 by 4 pi epsilon naught. This pi is getting cancelled. This 4 is getting cancelled. Sigma by 2 epsilon naught minus sigma by 4 pi epsilon naught, sigma by 4 epsilon naught, that becomes sigma by 4 epsilon naught. Okay. Taking the ratio EP by EQ, divide these two, what it will become? This will become 4 by 6. This is 4 by 6. So if this is 4 by A, I'll say A is equal to 6. A is equal to 6. Use the superposition, individually write the electric fields, take the resultant, that becomes my answer. Okay, another question, a uniformly charged disk of radius r, okay, this is I think, yeah, the same thing, having surface charge density sigma, placed in xy plane with its center at origin, the electric field along the z-axis, the same formula, electric field due to uniformly charged disk, and we know the formula, what is that? Sigma by 2 epsilon naught minus 1 minus, it is along z-axis, so z by z square plus r square whole to the power 1 by 2. B option is coming. Yeah, got it. Now, motion of charged particle in uniform electric field. So, if I talk about, if let us take a charged particle is there, let us take a charged particle, so having some charge Q, some charge, some mass M, it is placed here. Electric field is there, E, so how much will be the force on this? You will say that will be E into Q. Yes, that will be E into Q. So considering, let us take some electric field is there in this direction. So you will say if the electric field is E in that direction, the force on this will become E into Q. Okay, simple. So when I write the force, I'll say force is simply the electric field into the charge. If the charge is positive, the force is in the same direction. If the charge is negative, the force is in the opposite direction of the electric field. Try to understand this. If charge is positive, the force will be in the same direction, because you see it's positive. If charge become negative, a negative sign will come. Multiply a vector with negative sign, vector become opposite, force will become in the opposite direction. From here, if I write the acceleration, that will become EQ by M. And then you can analyze it. If some initial velocity is also there in one direction, you can also consider that. Okay, and just take this acceleration and solve it further. If let us take some velocity is there, initial velocity along y-axis is there, and some initial velocity along x-axis is there. So you analyze the motion along x-axis and y-axis separately, as we do in projectile motion, because two perpendicular directions are independent. Just see what is the velocity acceleration in one direction, write the equations for that. Just see what is the velocity acceleration in the other direction, write the equations for that and solve it. Okay, I'll show you some questions on this. Yeah, we have this question. Read it out. A uniform electric field 8 m by E is created between two parallel plates of length 1 meter as shown. Mass is m, charge E of the electron. Okay, an electron enters symmetrically between the plates. Okay, between these two plates the electron is entering from here with speed 2 meter per second, the angle of deviation. So when it will pass from the plates, what will be the angle of this deviation? Theta. Now try to understand this. Charge is electron, this is a negative charge. It will have, electric field is in the downward direction, it will have force in the upward direction. Due to that, it will have some acceleration in the upward direction. So when it will pass, it will gain some velocity in the upward direction. What about in the horizontal direction? That will remain the same. There is no force in the horizontal direction. There is no acceleration in the horizontal direction. Therefore, the velocity in the horizontal direction is not going to change. So, if I say the initial velocity in the horizontal direction is 2 meter per second, this is also 2 meter per second. That is not going to change. Only thing I need is what is Vy, the velocity along y-axis. Then I can find theta here, because tan theta I can say Vy by Vx simply. So what is Vy? How to write that? First of all, let us see what is the acceleration in y direction. So if I write the force, charge into electric field, magnitude of charge is E. So E into the electric field, that is 8 m by E. Divide this with mass to get acceleration. So this getting cancelled, and from here I got A as 8 meter per second square. Acceleration I got, it is 8 meter per second square. How I'll get the velocity? I need time. How can I get time to cross this? I know the width, know the distance that it is covering along x-axis, that is 1 meter. Know the velocity along x-axis, that is constant, that is 2 meter per second. So how much time it will take to cover that distance? Time is equals to distance divided by speed, because that is constant. So time is 1 by 2 seconds. Acceleration is this. Along y-axis if I write, v is equals to u plus at. Initial velocity along y-axis 0. What is the final velocity along y-axis? A into t. A is 8, t is 1 by 2. So Vy is basically 4 meter per second. So this velocity I got as 4 meter per second. Okay, I got horizontal velocity, got vertical velocity. Can I find this angle tan theta? Can I find angle this? What is theta? Because the answer in terms of tan inverse, therefore I am saying tan theta. So I'll say tan theta is Vy by Vx in this right angle triangle, isn't it? The perpendicular by the base. So tan theta is Vy by Vx. What is Vy 4 by Vx 2? So tan theta comes out to be 2. So this is tan inverse 2. This is tan inverse 2. That becomes my answer, second option. Okay. Everything seems fine. So here the some fundamentals of kinematics you may say, and other thing is just write the acceleration by finding the electrostatic force. Okay. Another question, let us read it out what it is mentioned. A particle of charge minus q, mass m, moves in a circle of radius r around an infinite long line charge of density lambda, then the time period will be. Okay. So here what is happening is there is a long line charge, let me show that we may consider it like this. Okay, so it's a very long, like this. The charge particle is moving in a circle around it. So when it is moving in a circle, what the charge particle is? Minus q. Okay, and the line charge is plus lambda, then only it can move in circle, because otherwise it will repel. If both are positive, they will repel each other. So this is negative minus q, and here the charge per unit length is plus lambda. So due to this, it will pull it, some electrostatic force will be there, and this electrostatic force will be mass into the centripetal acceleration, moving in a uniform circular motion. So if I write it, this F electrostatic is equals to mass into the centripetal acceleration there. What is F electrostatic? I'll say that is electric field into charge q. Magnitude I just need to write. What is electric field due to a uniform, I'll say due to a long infinite wire, uniformly charged wire, 2k lambda by r. So that is 2k lambda by r into the charge q is equals to mv square by r. R is getting cancelled. Velocity I got from here is a root of 2k lambda q by m. This is the velocity, and if I have to write time period, that is 2 pi r by v. Okay, so 2 pi r by v. So if I do it like this, numerator m will go in the numerator, divided by 2k lambda q, 2k lambda q. This becomes the answer, the time period. Checking the option. Which one is that? 2 pi r root of m by 2k lambda q. M by 2k lambda q. B is the correct option, isn't it? Yeah. Yes. B is correctly matching here. Okay. So writing force, that is in a circular motion. Now you may say varieties can come, isn't it? Core concept is the same. You need to understand how to write electric field due to a uniformly charged infinite wire. Now so many varieties can be there. The charge particle is moving in a circular motion, that is one variety. Writing electric field due to that, another variety. Okay, electric field due to that wire and taking an infinite sheet, another variety. So varieties can be so many things. Okay, so many varieties can be made here using the same fundamental concept. You need to learn one small thing, that what is the electric field due to this you can say charge distribution. That's all. Another question we are having, a body having specific charge, that is 8 microcoulomb per gram, is resting on frictionless plane at a distance 10 centimeter. Okay, so here this distance is 10 centimeter initial from the wall as shown in figure. It starts moving towards the wall when a uniform electric field of 100 volt per meter is applied horizontally towards the wall. If the collision of the body with wall is perfectly elastic, then the time period of motion will be. Now what happens, it is initially at rest, it is having some charge, okay, that is specific charge is given. Now you apply electric field, what will happen? It will gain some velocity, it will move like this, gain some velocity, it will collide with the wall. Now it is given the collision is perfectly elastic, so it just collide. Okay, just after the collision the velocity will become opposite, again it will come back. So it will go like this, collide, and after collision it will move in the upward direction with the same velocity. Okay, then electric field is opposite, now it will slow. Initially it was accelerating, now electric field is in the opposite direction, velocity is in this direction, so it will slow down, slow down, slow down, again come back to rest at that point. So it will go, strike, come back, go, strike, come back. This is how the motion will be. Time period means of one complete cycle, means going, striking and come back. And I can say that the time it will take to go and strike will be the same as the time it will take to come back at that point, because if you throw a ball vertically upward, okay, it will come back. The same time it will take to go up, same time it will take to come back when the acceleration is uniform. So acceleration is uniform, therefore I am saying this. So what is the time it takes to go and strike? Let us take that as t. So the time period will become twice of this t. This t, the time to go from here to the ball. That is my t. Now how to find that t? Initial velocity is known, acceleration we can find, from there we can write the time. What is acceleration? Force, that is eq divided by m. Electric field is 100 volt per meter. This is 100 volt per meter, okay? Yes? Yeah, 100 volt per meter. And what is q? Q is, okay, q by m is given, specific charge, that is 8 microcoulomb per gram. So 8, I'll write it, this is 8 microcoulomb per gram, converting that to kg. Everything is fine? Yes. So this becomes 0.8, 10 to the power, this is 3 plus 2, 5, so 0.1, so 0.8 will become, yes, 0.8 is the acceleration. So how much time it will take to go and strike, starting from rest? So the distance is equals to half at square. So half a t square is my distance, let us take that as L. So time is root of 2L by A. So what is that? Root of 2L by A. So 2 into, what is L? L is given as 10 centimeter. Yes. Where it is mentioned? I lost. Yeah, here it is mentioned 10 centimeter. So 0.1 divided by A is 0.8. So this becomes a root of 1 by 4. So that is 1 by 2 seconds. So 1 by 2 seconds to go and strike, 1 by 2 seconds to come back. Total time period becomes 1 second. So the answer is 1 second. 1 second is the answer. Again, I'll say here this motion is periodic motion, oscillatory motion, but not simple harmonic, because you know here the acceleration is constant. Acceleration is not of type minus omega square x. No, that is constant. It's a periodic oscillator. Go, strike, come back, go, strike, come back. It will continue like this. So it's a certainly I'll say again a multi-concept question. So many things, so many varieties can be there. That is the point here. Now coming to our next topic, that is electric field lines. Now electric field lines is basically the way of representing the electric field. We show electric field, okay, like I was saying that if a charge is there, two charges are there, how they are applying force on each other due to the presence of field. Due to one charge, I can say field is there, okay, that field is applying force on that other charge, okay. So now how to represent that particular field in you can say form so that we can visualize it. This is the way of electric field lines. So if a positive charge is there, let us take, this is charge plus q. So we show the field lines coming out of this. When we show electric field lines, we'll show coming out like this. At a particular point, if we have to find direction of electric field, how to find that? The tangent at that point to the electric field lines, okay. So if I have to find, let us take electric field at this point. So take the tangent. Now this is a straight line. So here the direction of electric field is this, okay. So electric field lines gives you the idea of the direction of electric field. Next is, it gives you the idea of relative strength. If let us take at a point, here if I talk about, here the field lines density is very less, the field lines are away, it means the field strength is very less, means the magnitude of electric field will be lesser here. If I take point very closer here, the field lines density is greater. So here the electric field strength will be greater. So closer, I'll say, where the lines are closer, it means the field strength is more. If the lines are away, means the field strength is less. So it gives you the idea of field strength, or I'll say relative field strength. It will not tell you the exact magnitude. It cannot tell you the exact magnitude at a particular point, but you'll get a relative idea. Oh, here the field is very large and there the field is very less. This is what I am saying. Okay. So, on the other side, if I draw the field due to negative charge, let us take negative charge minus q. So, it will show the field lines entering. Okay, like this will show. Now, how many number of field lines to show? It depends on you. But if let us take two charges we are showing, one is having q, another is let us take 4q. So, the number of lines you will show for 4q must be 4 times that of q if you show, because that should come in the, you can say, representation that this charge is 4 times. So, the field lines you will show will be 4 times as that. If you draw 10 lines for this, for 4q you have to draw 40 lines, okay, 4 times of that. Okay, let us take if there is a positive charge and a negative charge, both are present, how will the electric field lines will be? So, let us take this is a positive charge and this is a negative charge. The field lines will start from positive and at negative. Okay. They will also end after covering a large distance. Similarly, they will come like this here after covering a large distance. One of the point is electric field, the electrostatic field lines, means here the charge is static, it's not moving. The electrostatic field lines never form closed loop. They never form closed loop. Why? Because it starts from positive charge, it ends at negative charge. It will not form a closed loop. You see, there is no closed loop. You will say, sir, this is a closed. No, the direction if you see, it's going like this is also going. There is no closed loop. No two field lines can intersect at a point. This is a fundamental, I'll say, question that is many times asked, even in CBSE and like other board exams also it is asked. So, why the two field lines cannot intersect at a point? Because at a point, how we find the direction of electric field? Tangent, take the tangent. So, if two are intersecting, two directions of tangent there, then is it possible to have two directions of electric field at a point? No. Therefore, we say two electric field lines cannot form cannot intersect each other, and the field lines cannot form a closed loop. That point is clear to us? Yes. Okay. Now, one more thing I can show you. This was due to positive. I can show you due to negative also. Let us take two negative charges. Minus q, minus q. How will we draw the field? Now, field lines will come and end at minus q. Okay. Oh, I did a mistake in the direction. Yeah, I did a mistake in the direction here actually. This direction is wrong. It's coming out. I should. Yeah. Oh, I did a mistake. Anyways, I am redrawing it. Negative charge is there, so field lines are not coming out. they are going inward. Okay, so I am drawing it again. Just got confused. Okay, this is going inward. Okay, like this. Oh, again, yeah, I did the same mistake. It's going inward. Let me use eraser. Yeah, it is going inward. Perfect. Yeah. So here by visualizing the field lines only we can see, yes, they are repelling each other. Okay. And here if you see these field lines, it shows they are attracting each other. Similar type of you can say diagram will come, field line diagram will come for positive charge only, just the directions will become opposite. Okay, the field lines will be moving out. Okay, here we have a question. What it is asking, two charged thin infinite plane sheets of uniform surface charge density plus sigma and minus sigma, where plus sigma is greater. This is important to us. Intersect at right angle. Which of the following best represent the field lines for this system? Okay, here plus sigma is the horizontal one and the minus sigma is the vertical one. The plus minus sign is very small, so you may not be able to see it. Plus is the horizontal and the minus is the vertical one. Okay, how will we show the fields? So whether they will form circular loop, elliptical loop, or some shapes like this, we have to see that. Okay, let us do that. This is the quadrant, and here we will see this is plus sigma, plus is the horizontal, yeah, and this is minus sigma. Any point if you take on the first quadrant, what is the direction of electric field? We know due to this infinite sheet, the formula is sigma by 2 epsilon naught, and that is independent of the distance. So due to this, it is sigma by 2 epsilon naught, sigma plus by 2 epsilon naught away. Due to this minus sigma, it will be towards. So sigma minus by 2 epsilon naught. The resultant of these two, that will be like this, isn't it? Direction is not changing, magnitude is not changing, the electric field is uniform. One thing I forgot to tell you here, field lines. If the electric field is uniform, then the field lines, neither they should, you can say, go away or should come towards, okay, because the intensity, the distribution is same, so they should be parallel. Okay, so when we say for uniform electric field, we show the electric field lines parallel like this. The separation also same, the length of this is also same. Okay, this is how we represent the uniform one. Now, so here the electric field is uniform. Okay, so and it's straight line, it will go like this. In this quadrant, second, if you talk about, due to plus it will go like this, due to minus it will go like this. Again the resultant will be somewhat like this. In the third quadrant, if I draw, due to plus, due to minus, it will be somewhat like this. In the fourth quadrant, due to plus, due to minus, resultant somewhat like this, ending at negative, starting from positive. Okay, so one thing is they are straight line. Now we are having two diagrams, B and D. Which one is correct? Now you see this. Here they are mentioning that sigma plus is greater as compared to sigma minus. If sigma plus is greater, this angle with the horizontal will be greater, because if you write tan theta, that will be sigma plus by 2 epsilon naught divided by sigma minus by 2 epsilon. So this theta will be greater. So it will become like a bit compressed like this. This theta will be greater. So D is the correct match here. You see, in the B option, it is a square shape. This angle is for 45 degree. It would be 45 degree if both would be equal, but one is greater, another is lesser. If that is there, sigma plus is greater, so this vertical component will be greater, this angle will be greater than 45 degree, so it will become a bit compressed like this. Understood it? Like this question was asked in 2020, September 2020, but many of the students were confused. Like B and D both are similar, so which one was correct? So this thing was given in the question, and you had to understand it, that if one is greater, so one component will be greater. If that component will be greater, so use the theta. Okay, the theta will be greater than 45 degree. If this is greater than 45 degree, so it will become a bit like this. Okay. Back. So let us discuss about electric flux. So what basically flux gives us? So basically electric flux, I will say, is proportional to the number of field lines that is passing through an area. Let us take here, the electric field is in this direction and this is the area. Now you will say proportional to number of field lines. It means greater the flux, greater the field, greater will be the flux. So proportional to E, and greater the area, so proportional to area also. That should be E into area. No, there should be angle also. Why so? Let us take, if the area you place this, you can say sheet like this, parallel, then the flux will be zero. No field lines will be passing through it. So to passing through it, we need component of the area vector that is along the electric field. Now what is area vector? Many of the students may not be well versed with this. So area vector is basically the vector which is having the magnitude as that of the surface area and perpendicular to the surface area. Okay, this is perpendicular to the surface area, 90 degree here. So this area vector is perpendicular to the surface. So taking the component of the area vector that is along the electric field into the electric field. Okay, so that will give you the perpendicular area to the electric field. So therefore the flux is EA cos theta, and EA cos theta we can write as E dot A also. E dot A. So this becomes my flux. Okay, now this is when the electric field is uniform. What if the electric field is non-uniform? Or let us take some even some random area is there. Okay, the electric field is, let us take like this. So what you will do? So there what you need to do is, you'll take small section there. Its area, let us take, this is dA. Here the electric field is E. So the flux through this small section d phi, that will become E dot dA. That will become E dot dA, and then you integrate it both sides. So that will become the total flux, integration of E dot dA. If the electric field is non-uniform or the area also is like that, so you may take the integration of E dot dA. Now what is dA? We took a small area, that area vector is dA. Okay, there the electric field is E. So summation of, or the continuous integration, continuous summation means the integration of E dot dA. or I can say EDA, and if there is some angle, you may consider that angle, but that angle will be keep on varying for different, if you take, let us take, if I take small area here, the angle will change. So you have to consider that also. That is clear. Now, if the flux is, we will come to that also again. If the flux is going out, we consider that flux as positive. We will come to that when we will discuss Gauss law basically. First of all, let us do some questions on this basic understanding that flux is equals to E dot A when the electric field is uniform. We have this question on this. This question was asked on in January shift 2024. Simple question. An electric field line is given by this. Okay, electric field is given by this. The electric flux through the surface area, that is 30 I cap meter square in YZ plane is. Now when we write flux, use the formula E dot A. You know how to take the dot product. First I will write E, that is 6 I cap, 5 J cap, 3 K cap, dot 30 I cap. Okay, now when we take the dot product, we will multiply this with this. Okay, I, okay, 6 into 30, JK is 0, so need not consider that. So what is this? This is 180. Now what is the unit basically? Now here if we talk about what should be the SI unit of flux? Electric field into area. So electric field unit is Newton per Coulomb into meter square. That is the SI unit. So here I can write Newton per Coulomb meter square, but he is just saying the SI unit. We'll say the magnitude is 180. That is the correct answer here. Okay. Now coming to Gauss's theorem. So what is Gauss theorem or Gauss law? It states that, let us take, there are charges, some charges, Q1, Q2, Q3, Q4, Q5, Q6. You make some closed surface that we call as the Gaussian surface. Let us take the Gaussian surface as this. This we call as the Gaussian surface. So the Gauss law states that the total flux through this Gaussian surface is equals to the charge enclosed divided by epsilon naught. What is the charge enclosed in this particular case here? Here we are having Q1 and Q3, so I will say Q1 plus Q3 by epsilon naught here. Okay, this is my Gauss law. So charge enclosed is Q1 plus Q3. Now what about Q4, Q2, Q6 and Q5? Whatever field lines due to Q2 are entering, they will be exiting also. So total flux will be 0. Entering is positive, entering is negative, exiting is positive. Okay, so total positive negative, that will come out to be 0. Similarly, whatever field lines will enter due to Q4, same will exit due to Q6. So the total flux is independent, or I'll say will not depend on the charge which is outside, which are outside. Total flux. Now if you say, sir, will there be electric field due to these charges inside the Gaussian surface? Yes, field will be there. If you have to find field at some place, let us take at this point. So you need to consider Q1, Q3, Q2, Q4, Q6, Q5. All these charges you have to consider when you are writing field. But when finding total flux, just see what is the charge that is inside Q enclosed divided by epsilon naught. Now using this Gauss law, you can also derive the expression of electric field when you can say your Gaussian surface is symmetrical. You can take a symmetrical Gaussian surface to find electric field. We will do how to find that. Let us take a point charges there. Now if I ask you what is the electric field due to this point charge at a distance r from it, you know the formula, you will say, sir, that is kq by r square. Can you find due to by using Gauss law? Yes. We'll draw a Gaussian surface symmetrically. Let us draw. We'll draw a Gaussian surface symmetrically. Okay, like this. No, it's not perfectly like this. So symmetrically means like this. This is at center now. This charge is at center. So this is my Gaussian surface. Now if I take any area component, the electric field from symmetricity, I'll say it will be outside and same E. So the angle here is 0 only between the electric field component and my area vector dA. So when you'll write the flux, what you will say? The flux will be E into, because angle is 0 anyways, okay, and E is uniform, same everywhere, so it will just become E into A, and by Gauss law this is equals to, sorry, this was r square here, E into A, and by Gauss law this total flux from this Gaussian surface is equals to Q enclosed by epsilon naught. Q enclosed is Q by epsilon naught. So we got the expression of electric field as Q divided by 4 pi epsilon naught r square, or we say as kq by r square, the same thing. We have to consider a symmetrical Gaussian surface in which we can write the total flux. We can find E dot dA everywhere there on that particular surface. Let us do this exercise now. Electric field due to an infinite line charge. This is an infinite line charge. I have to find electric field at some distance. Let us take R. Here is my point P. I want to find electric field at point P. So what I will do? I am drawing a Gaussian surface. So this cylindrical surface I am taking as my Gaussian surface. Now for this cylindrical Gaussian surface, if I write flux Q enclosed by epsilon naught, what will be Q enclosed? You will say, sir, this much length of the uniformly charged wire is coming inside. Okay, this wire is having charge. Okay, so charge will be the length that is coming inside into charge per unit length divided by epsilon naught. So this becomes my flux. Now can I write that in terms of electric field? Yes. On this surface, on the top, if I write electric field is in, or means let us similarity, I will say it will be going away, and the area vector is like this. This will be my dA and this will be my electric field somewhat. So at all the points here the angle is 90 degree. So I will say through this surface the flux is 0, E dot dA, isn't it? If angle is let us take 90 degree, that is EA cos 90, that will become 0. Similarly, from this lower surface also the flux is 0. Now due to this curved surface, if I take any dA vector on this curved surface, this is my dA, and from symmetricity I will say the electric field will be away only. This is the electric field. E dot dA, angle is 0, so E dA cos 0, that is 1, so E dA, and when you will integrate, because everywhere E is same, so it will become just E into A. So E into A of curved surface area 2 pi RL. So from here I got E as lambda divided by, L will get cancelled, 2 pi epsilon naught R, or I can write this as 2k lambda by R. It's the same thing, it's the same formula that we already remembered, okay. Electric field due to uniformly charged infinite line charge, uniformly charged infinite wire. Now this is due to long hollow cylinder. If a hollow cylinder is uniformly charged, how to write electric field at a distance r? So if you take any point inside it, let us take here, you take a point and you draw a Gaussian surface, what will be the enclosed charge in this? 0. So what will be the electric field there? 0. Why? Because E dot dA, so from symmetricity E and D are in the same direction. E dot dA is not 0 because of that cos of 90. No, angle is 0 there. Okay. So, if I write for r less than r, electric field is coming out to be 0 because there is no charge inside the Gaussian surface. So, if I write r greater than r, I am taking a point somewhat here, let us take, and this bigger cylinder becomes my Gaussian surface. Again I will say from this area the flux is 0, from this area the flux is 0. It will just become like whatever is the charge enclosed, charge per unit length into the length by epsilon naught. This is my flux, and this will be E on the curved surface into my area, that is 2 pi RL. Again the same formula, that is 2 k lambda by r. It will just behave like a wire. It will just behave like a wire, okay, placed along its axis, and we can write electric field at a distance r, that is 2 k lambda by r. Simple thing. Okay, moving further. Now here electric field due to this is a charged and long uniformly charged solid cylinder. Due to long uniformly charged solid cylinder. This should be deleted. Okay. Long uniformly charged hollow cylinder. Solid cylinder. Now, if you take any point outside, the expression will remain the same. You got what was capital R previously in previous question, or you are confused? Oh, capital R was this, okay, the radius of this cylinder. Yeah, here it was not mentioned, so therefore I was worried. This is my capital R. So again, if I take any point outside, the expression will remain the same, 2 k lambda by r, and you can find charge per unit length. If let us take charge per unit volume is given to you, if charge per unit volume is given to you, you can write charge per unit length as rho into the area of cross section of this, that is pi r square. Okay, so for outside it will just behave like a wire that is placed along its axis. For inside, any point, let us take, you are taking somewhat here, the small distance r, I'll say small r it is. I'll draw a Gaussian surface. For this Gaussian surface, I'll say the total flux is equal to Q enclosed, which is charge per unit volume, into pi r square into, let us take the length is L, divided by epsilon naught. Okay, and this is, I can say, on these two horizontal surfaces, the charge, I'll say flux is 0, only through the curved surface the flux will be there, and what it will be, E into 2 pi RL, L will get cancelled, 1 R will get cancelled, pi will get cancelled, so E is coming out to be rho R by 2 epsilon naught. Do we need to remember this formula? No, need not remember this formula. You can just understand the concept. This is what is required from here. Okay, electric field due to a shell or hollow non-conducting or solid conducting charged sphere. Now let us consider this is my shell. Let me make it more spherical by using the shapes from here. So why so many ores are there, or this or this? Because in each of the case that is mentioned here, the charge will be on the surface only, uniformly distributed. And let us take this charge as Q. Now, if I ask you what is the electric field at any point inside this, first of all, let me mark the radius. So, if you take any point inside this, let us take this as my point P, okay, and this point P is at a distance r. which is less than the radius, and I ask you what is the electric field here, so what you will say? Okay, you will say that we will draw a Gaussian surface symmetrically like this. For this Gaussian surface, if I write the flux Q enclosed by epsilon naught, this will become 0. So 0 is equals to E into the area. So anyways, you are getting E is equals to 0. So for R less than R, the electric field is 0. Now if you take any point outside this, let us take this is my point P, at a distance R which is greater than R. So you will say that we will make this as the Gaussian surface, okay, and for this Gaussian surface, when I will say flux which is Q enclosed by epsilon naught, so total charge is enclosed now, okay, and at any point whatever is the direction of area vector, that is the direction of electric field, okay, and E is same everywhere, so it will just become E into A 4 pi, sorry, this was small r square. So electric field becomes Q divided by 4 pi epsilon naught r square, or KQ by r square. KQ by r square. So it just behave like a point charge having the same charge as that of this shell placed at its center. Okay, if a shell is there, inside if you write, electric field is 0. Outside it will behave like a point charge at its center, KQ by r square. Simple. Now if I draw the characteristic how E is varying with distance, till r is equals to r, electric field is 0, and after that it will become, till r is equals to r, the electric field is 0, and after that it will become 1 by r square. Proportionality is there. Okay, so it will go like this. Okay, this is KQ by r square. This formula many of you already remember. If you not remember, you should remember it. Okay. Next thing is electric field due to solid non-conducting charge sphere. Now next case, we are having a solid non-conducting charge sphere. It means the charge is distributed in the volume. If the charge is distributed in the volume, it is having charge like this everywhere. Now again the two conditions. What is the electric field at a point which is at a distance small r less than the radius of this sphere? You will say we will draw this as the Gaussian surface. Okay, and for this Gaussian surface we will write flux as Q enclosed by epsilon naught, and this is my, at any point if you take the electric field symmetricity, I will say electric field is like this, area vector is also in the same direction, everywhere the electric field is same, it will become just E into A like this. So point is how to write Q enclosed. Let us take total charge is Q. Now here it is mentioned that this is uniformly distributed. This is uniformly distributed. If Q is uniformly distributed, I will say Q enclosed is charge per unit volume. This is total charge by total volume into the volume of this through which I am trying to find the charge, inside which I am trying to find the charge. So Q r cube by r cube. Q enclosed I got, I will place here. So Q r cube by r cube, this is E into 4 pi r square, this r square will get cancelled. So E is equals to Q, this epsilon naught was also there, Q enclosed by epsilon naught. So this will become Q divided by 4 pi epsilon naught r cube into r here. This is for r less than r. If we talk about r greater than r at any point somewhat here, let us take, you will say we will draw this as the Gaussian surface. This is my Gaussian surface for the second case, r greater than r. So if I write the flux q enclosed by epsilon naught, this will become E into 4 pi r square, the area. Q enclosed is q only, q by epsilon naught is equals to E into 4 pi r square, and you will say E is equals to q divided by 4 pi epsilon naught r square, which is just kq by r square, and it will again behave like a point charge which is kept at the center. So even if solid uniformly charged sphere is there, any point if you want to find electric field outside it, it will behave like a point charge which is kept at center. Inside it, the electric field is increasing with distance r. Outside it is decreasing. So if I draw the shape, how it will vary? So first it will increase with distance like this till r is equals to r. After that it will decrease like this, 1 by r square proportionality. This is E versus r. This is kq by r square. Okay, like if you see the previous one, here the inside it was 0, outside it was having the same relation. Here inside it is not 0, it is increasing, outside it is having the same relation. Okay, due to an infinite sheet, you know already the formula, that is sigma by 2 epsilon naught. Okay, but let me show you. Let us take, this is my sheet. I am drawing this in 3D, okay, going inside like this. Uniformly charged. Now here I will draw a Gaussian surface, a cylindrical Gaussian surface crossing through this sheet, placed symmetrically. Okay, it is placed symmetrically. Now this is a large sheet. Electric field from symmetricity, I will say it is just going away. So at any point on the curved surface, electric field is like this, area vector is like this, angle is 90 degrees. So from the curved surface the flux is phi. From the curved surface the flux is phi, 0. Flux, that is 0, because E dot A, if you write angle is 90 degree, that will become 0. From the curved surface, if you, from the flat surface if you write electric field is, let us take E here, the area of cross section, let us take A here. So both are in the same direction, so the flux here will become E into A. Similarly on the other side, if you write this is E, again this is A, flux is E into A. So the total flux that is coming is 2EA, and that is Q enclosed by epsilon naught. Here the surface charge density is sigma. Surface charge density. Surface charge density is sigma. So I will say from here that Q enclosed is sigma into A, because that only portion is coming inside this Gaussian surface. Okay, so sigma into A charge is coming inside. So Q enclosed is sigma into A. A got cancelled. Electric field we are getting as sigma by 2 epsilon naught, and that is away from the distance. We got this same formula. It is independent of the distance from the sheet. Okay, some questions on this, let us do them. So 5 charges, these 5 charges are given to us, situated as shown. The electric flux to this configuration through this surface S is. Now flux we have to write, we will say that is Q enclosed by epsilon naught. What is Q enclosed? Inside only 5Q minus Q plus Q, 6 minus 2, 4Q. So 4Q divided by epsilon naught. 4q divided by epsilon naught. B option. And these type of questions are asked in JEE mains. You may say, sir, this is very easy. This may be easy, but this is what is asked here. You see, this is here what is asked. So these fundamental things are asked. You need not worry that this chapter is very difficult. You are able to understand it. Another question. Two infinite plane, each uniform surface charge density plus sigma are placed here. The angle between them is 30 degree. The electric field in the region shown between them is, okay. In between I have to show. I know due to one sheet the electric field is sigma by epsilon naught, but here two are placed at an angle 30 degree. So at any point here if I write the electric field, I'll write due to the two, both the planes, okay, and take the resultant of that. That is the principle of superposition. So due to this, if I write, it is in this direction, sigma by 2 epsilon naught. Similarly, due to lower sheet, if I write, that is in this direction, sigma by 2 epsilon naught. Okay. Now, what is the angles here? We have to write in I cap j cap form. This is the horizontal. And how much is this angle? This is 30 perpendicular to this, total is 90, so this is 60. So this angle I will say this is 60. So if I take the component of sigma by 2 epsilon naught, so this vertical component when we will write, that will become sigma by 2 epsilon naught sine 60. Sigma by 2 epsilon naught sine 60, and this is sigma by 2 epsilon naught cos 60. So if I write the electric field in the horizontal direction and in the vertical, so in the vertical direction it will become sigma by 2 epsilon naught 1 minus sine 60. Sine 60 is root 3 by 2. This is along y-axis, so y cap here they are using instead of j cap, so I will write y cap. Along x-axis it is towards the negative x-axis, so minus. So minus sigma by 2 epsilon naught is taken common, so I will take this as common. So this will remain cos 60 just, so 1 by 2 x cap. So 1 minus root 3 by 2 y cap minus 1 by 2 into x cap, and outside we are having sigma by 2 epsilon naught. Yes, we got A as the correct option here. Just we need to take the components carefully. Another question. Consider a sphere of radius r which carries a uniform charge density rho. If a sphere of radius r by 2 is carved out of it as shown, what is EA and EB? Now these type of questions how you have to consider. This was total charged uniformly. Out of this you can say sphere is carved out. Now I can consider this as the resultant of two spheres, one this complete bigger one that is positively charged plus this which is negatively charged. This is, let us take, having plus rho, this is minus rho. If you sum up the two, it will become like this portion is removed. Okay, so I will use superposition. At any point if I have to write electric field, I will write due to this plus and due to minus take the resultant. Okay, now if I consider the charge on this plus this I will say the complete sphere as plus q, if I consider this charge as plus q, how much is the charge on this negatively charged sphere? How much it will be for that? The volume is, the radius is half, volume is 1 by 8, charge will also become 1 by 8, so minus q by 8. Got it? Now let us write electric field at A and B. If I write electric field at A, due to complete at A means at center, what is that? 0. Only remaining is due to this half. If I write the electric field at, this is the point A, what it will become? K, just need to write the magnitude, K into Q divided by the radius square. So EA is coming out to be K into Q, for this is Q by 8 divided by r square r by 2. So r square by 4. So this is kq by 2r square. EA we got. Now EB at this point B. At this point B, due to complete one, this is the point. If I write, what it will become? KQ by r square. So KQ by r square. Due to minus, if I write, so that point is somewhat here down. So from its center, the distance will be 3r by 2. Means I am saying from here the distance is r plus r by 2, 3r by 2. So that will become k, minus sign is there, k q by 8 by 3r by 2 whole square. Got A, EA and EB. Take the ratio of EA and EB. Okay, and if you do this, you will get EA by EB as 18 by 34. It will come out to be 18 by 34, which is option A. So these variations can come. Some portion is removed. Take that as a superposition of one complete whole as positively charged and the remaining removed portion as the negatively charged. So this is how you have to do such type of questions. Another question, this was asked in JEE Advanced 2022 and this is very simple question. What is asking here? A charge Q is surrounded by a closed surface consisting of an inverted cone of height h and base radius r. So inverted cone is there of height h and base radius is r. The electric flux through the canonical surfaces. Now here this charge Q is placed at its center here and we have to write the flux that is through this cone. How to do this? Now one simple thing if I ask you, if I make this as complete sphere, now if I ask you how much flux is passing through upper half and lower half, you will say it is symmetrically placed at center. Q by 2 epsilon naught, total is Q by epsilon naught. So Q by 2 epsilon naught from the upper, Q by 2 epsilon naught from the lower. So from the upper how much is passing? Flux Q by 2 epsilon naught and from the lower Q by 2 epsilon naught. Now even if this is a cone, that flux only will pass through here, isn't it? So what it will become? Just Q by 2 epsilon naught. Just Q by 2 epsilon naught. So the answer is Q by 2 epsilon naught and this is given as NQ by 6 epsilon naught. So from here I can say N comes out to be 3. N comes out to be 3. Okay, another question we are having. Let us read it out. An electric field E that is given to us passes through the box as shown. The flux of the electric field through surface ABCD and BCGF are marked as phi1 and phi11 respectively. The difference of the two. Okay. Through which two surface? Through phi1 is through ABCD. Through ABCD if I see, the area vector is along z axis. Is there any component of electric field along z axis? 0. So if you do E dot A, that is 0. So flux is 0. So this phi1 is 0. Now phi11. Phi11 is through what is that? BCGF. BCGF. This. What is the electric field along x axis? 4x. Here my electric field is 4x. X is constant. What is x there? X is 3. So electric field is 12. What is area? If I ask you area, so that is area is this side. This is along y. So this is 2. And this side, this is along z. That is also 2. So area is 4. So area is 4. Flux E dot A, that will become 12 into 4, 48. Okay, so here if you subtract that, that comes out to be minus 48 in Newton meter square per coulomb. Got it? Another question. A point charge of plus 12 microcoulomb is at a distance of 6 centimeter vertically above the center of a squared side. This is a squared side. Above the center, 6 centimeter above this, the charge is placed. The magnitude of electric flux through the square will be. Now, this type of question you might have seen at many places. So, how to visualize this? Now, I will help you. Let us take, it is somewhat like a cube is there and the charge is placed at its center. At center means half the side of this square, half the side of this square, because this is half of this. And you are asked what is the flux through this lower surface. Is the same condition? Yes. Now this charge is placed symmetrically. Total flux is Q by epsilon naught. There are 6 faces, all are having equal flux. So from the bottom one, I will say it will be 1 by 6 of the total flux. 1 by 6 of the total flux. Simple. Now I have to put the values. The point charge Q is 12 microcoulomb. So 12 into 10 to the power minus 6 divided by 6 epsilon naught. 6 into epsilon naught 8.85 into 10 to the power minus 12. That's all. You just do calculations, you'll get the answer from here. Simple conceptual question. Now we are moving to the last topic of this discussion, that is electric dipole, and this is one of the most important topic. The questions are asked from this both in mains and advanced, and this dipole is one of the, I'll say, confusing topic for many of the students, but I'll help you out. Electric dipole, it's a combination of two equal and opposite charges plus Q minus Q placed at some separation. The dipole moment is defined as the charge Q into the separation D. This is the dipole moment, and the direction of this dipole moment is from negative to positive. It is taken as from negative to positive. So this, let us take this direction is whatever it is. If it is I cap, you may write here I cap. So this becomes my dipole moment. Dipole moment is a vector, it's not a scalar because the direction is here. If somebody asks you what is the unit, you will say this is charge having unit coulomb, this is distance having unit meter. So the unit is coulomb meter, isn't it? Coulomb meter, simple. That's all about this dipole. Now it's a combination of 2 points. Whenever you have to analyze, if let us take, you have to analyze, you consider it like 2 point charges which are placed at some distance, and then you can analyze that condition. That is simple. But if you know some formulas before only, so it will save your time. So therefore, I'll tell you. First of all, here we are having a question first. Determine the electric dipole moment of 3 charges placed at the vertices of equilateral triangle as shown. Now what is the dipole moment of this system? So here I can consider 1 minus q here, 1 plus q here. So this becomes one dipole moment. Another minus q, another plus q, this is another dipole moment in this direction. Magnitude is the same for each of that is q into L. So this vector is having magnitude q into L. This vector is having magnitude q into L. Both are at an angle of 60 degree. Okay, the resultant of that will come somewhat like this, and what it will be? QL cos 30, here also QL cos 30. So this is 2QL cos 30, and the direction is minus j cap. So that will become minus QL root 3 j cap. Okay, just solve it like a vector. Another question. Find the dipole moment of the system where Q charge is distributed on the semicircular ring uniformly. Now these type of questions, ring is there, it is uniformly charged. How to find dipole moment? Now first of all, I'll show you how you have to integrate it to find that, and then I'll tell you a trick. Using that trick, you will do this in just few seconds. Okay, so first of all, you take a small segment at an angle theta, which is making an angle d theta. This small segment, now this is some positive charge dq. Take small positive charge minus dq from here. This becomes one dipole moment, minus to plus. Okay, that is your dp. Write that dp, integrate theta from 0 to 180, you will get total p. How? This is charge. If I write charge per unit length here, let us take charge per unit length will be q by pi into the radius. How much is the radius? Let us take that is r. So if I write dq there, that is length into charge per unit length. So lambda, this is charge per unit length into the length r d theta. Okay, so lambda is q by pi r into r d theta. Got it? So this is q by pi d theta. This is dq. Then what is dp? Length is r, charge is q. Okay, so r dq is q by pi d theta. If I take the components, cos theta I cap, sin theta j cap. Cos theta I cap plus sin theta j cap. Now I have to integrate it. Theta goes from 0 to pi. Okay, so QR by pi is a constant, taking that out, cos theta integration is sin theta, just writing it, cos theta integration is sin theta I cap 0 to pi plus sin theta integration is minus cos theta j cap 0 to pi. I cap integration will become 0. This is 2qr by pi. I wasted so much time in this, but if you are smart, just take the center of this charge. You know the center of mass of the ring where it is 2r by pi. Just take the center of this charge, that is at a distance of 2r by pi. Place your entire charge q there. This becomes your dipole moment. What is the charge q? What is the distance 2r by pi? What is the direction j cap? It just took me 10 seconds to write if you consider the center of charge. Okay, got it? Now finding the electric field on axial point and equatorial point of a dipole. Two charges, minus q plus q. Okay, and let me draw the line here. Okay, let us consider there is a point here P at a distance r from the center. Here I need to find the electric field. Given that this distance between the dipoles is very small as compared to r, this assumption is there when I'll write that expression. Okay, so due to both the charges, I'll write due to plus q charge, the electric field is in this direction, k q divided by this distance will become r, this distance will become r minus d by 2. So r minus d by 2 whole square. Due to negative charge, it will be in the other side, minus of what? Kq divided by distance will be r plus d by 2 whole square. If I take kq common out and take LCM, so this will become r minus d by 2 square, r plus d by 2 square first, then r minus d by 2 square divided by, this is r square minus d by 2 square whole square. This becomes the expression. Seems a bit complicated. Hold on for a second, I will simplify. Kq, from here 2ab part will add, everything else will get cancelled. So it will become 2 into r into d divided by, d is very small, I'll neglect d square in front of my r square, so this will become r to the power 4. So this will become here, this q into d will become p. Yes, so 2kp by r cube. What is the direction? Resultant is towards the right, and that is the direction of my dipole moment, minus q to plus q. So the direction is just the direction of p only. So on the axis it comes out to be 2kp by r cube. You must remember this formula. This is very important. Next is on the equatorial point. So on equatorial point, let us take again, let me draw a dotted line first. Yeah. So considering this is my minus q charge, this is my plus q charge, there is a point P somewhat here at a distance r, the distance between the two charges is d. What I will do, I will write the electric field due to each point charge there, take the resultant of that. Let us do that. So due to minus q, the electric field is in this direction E. Due to plus q, it will be away, magnitude will be the same E. If this angle is theta, E cos theta, and this will also be theta, E cos theta will get cancelled. Horizontal will add 2E sin theta. So total electric field is 2E sin theta. 2E sin theta. What is E? KQ by R square. So KQ divided by R square. This distance. That is root of d by 2 square and r square, this small r square. So it will become basically, when I do square, so root will be removed, so it will become r square plus d by 2 square like this. Got it? Okay, into sine of theta. What is sine theta here? If I write sine theta in this right angle triangle, this is theta, so perpendicular d by 2 divided by hypotenuse. R square plus d by 2 whole square. D by 2, q into d will become p, so kp. Here again d by 2 square I will neglect in front of r square, so this will become r cube. What is the direction? Electric field is towards the left, dipole moment P is towards the right, so this is minus of P, so minus of Kp by r cube. This becomes my electric field at equatorial point. This formula is At most important, you must remember this formula, never to skip this. Got it? Never to skip this formula. So these two formula you must be remembering with sign. This is negative, opposite direction on the equatorial line. Now at a general point, this is not much required for mains, but anyways, if you want to write, I'll tell you how to write that. This is not much required for mains. Let us take, this is my dipole here. P, and I have to write electric field at this point. This is my R and this angle is theta. So how will I proceed? I'll take the components along and perpendicular, okay, of the dipole moment. So if I take the components of the dipole moment, so this will become my P cos theta. The perpendicular will become P sin theta. Due to P cos theta, if I write the electric field on the axial point, 2k P cos theta by R cube. Due to P sin theta, if I write the electric field here, this is on the equatorial point, minus Kp, therefore in this direction. So this is K P sin theta by R cube. Take the resultant to find the total electric field there. If I write the total electric field there, it will become Kp by R cube as common, root of sin square theta plus 2 cos square theta. So this will become 1 plus 3 cos square theta. So this is how you have to write that. But this formula is not required for mains. Don't remember this formula. Just understand this concept. If required, you can derive it. Don't worry. Now, torque on electric dipole. How to find torque? Here I am talking about in uniform field, okay. Let us take, the field is like this, okay. My dipole, कितना और हो गया, इसके आगे है किसी का? यार थोड़ी देर और होती तो हो जाता मेरा कंप्लीट। 5 बजे से होगा? अच्छा तो है, थोड़ा सा पॉसिबल है? किसी का रिकॉर्डिंग है कि क्या है? लाइव है तो 5 मिनट और कर लूँ, इसको तो पूरा कर ही लूँ, ठीक है। And let us take the dipole as like this here at some angle theta. This is my plus q charge, this is my minus q charge, okay. Now I have to find torque. So what I will do, I'll write the force on each of the charge first and try to write the torque due to that about its center. So if I write the force, so this force EQ, how much is this distance? This is d by 2, you see this is d by 2, so this distance is d by 2 sin theta. So about center the torque here is EQ d by 2 sin theta. Similarly on the other charge also if I write, it will come the same and the direction will be just adding it up. So it will become EQ d by 2 sin theta. That will become the torque. And this will come out to be EQ d sin theta. So this is E into QD becomes my P sin theta, okay. Now, if you see the direction of the torque, how it is trying to rotate it? Like this, okay, and that is the direction of my P cross E, okay, that is inside the plane P cross E. So this torque becomes, expression for the torque becomes P cross E. So this is the formula for the torque on electric dipole. And now let us discuss about simple harmonic motion of dipole in uniform electric field. So let us discuss now SHM of dipole in uniform electric field. So in a uniform electric field, we discussed that the field lines are like this. Let us take the dipole is first, initially I'll take the dipole is parallel, okay, to the electric field. Let us take the dipole is like this. This is my dipole. Now here if I ask you what is the torque on dipole, you will say P cross E. The angle is 0, so the torque is 0 in this condition. Okay. Now if I displace it slightly by some angle theta like this, so what will happen? Torque will come. In which direction the torque will be? P, this is P cross E. Okay, so it will try to rotate like this. It will try to rotate, means it will try to align itself in the direction of electric field. So actually this is its stable equilibrium. In the direction of equilibrium, in the direction of electric field, it is in stable equilibrium. Now you may say, sir, if we align in this direction, this is also equilibrium, but that is unstable. Why so? This is unstable, torque is 0, but if you slightly displace it by small angle, what it will happen? It will move like this. Okay, slightly displaced, it will move like this. So this is stable equilibrium. Now from stable equilibrium, you displace by some angle, it will oscillate like this. It will oscillate like this. Now how to find the time period of oscillation? Now let us take, I displace it by small angle, that is theta. What is torque? You will say, sir, torque formula is P cross E, that is PE sin theta, isn't it? Now if this is PE sin theta, if I say you, if theta is very small, theta is very small, torque is PE into theta, and that is in the opposite sense of the rotation. Like if you rotate it slightly like this, torque will be in this direction. So a negative sign is there. I means it's a restoring torque, and torque is, I'll write as I alpha, and for simple harmonic motion alpha is minus omega square theta. So here also minus is there, there also minus is there, so that will get cancelled. So omega square theta like this. What is I? I is our moment of inertia. Okay, moment of inertia about the center. So from here I can say that theta will get cancelled and omega comes out to be P E by I root of this, and time period 2 pi by omega. So you can write it 2 pi root I by PE. Okay, so this is how we can find the time period of oscillation of you can say dipole in uniform field. Now next is potential energy of electric dipole in uniform electric field. How to find potential energy? Let us take again, this is the uniform electric field. I am taking a dipole initially like this, and let us take, I am rotating it slowly and rotated it by an angle theta, and I'll ask you how much work I did in rotation. So you will say you have to apply same torque in opposite direction, isn't it? Like if equal and opposite torque only I have to apply, so that I can rotate it slowly. Angular acceleration is 0, total torque is 0. Whatever torque is due to electric field, same amount of torque I have to apply. So what will be the torque at, let us take this final angle is theta naught. So at any angle theta, if I write torque, so for theta I will say the torque will be magnitude, that is PE sin theta. This is my torque. So how much work I will do? work you know, that is W. This is integration of tau dot d theta. So this is integration of PE. This is sin theta d theta. And theta, I am considering that the theta that we have to take with the electric field. So with electric field, initially the theta was 90 degree. Okay, initially it is 90 degree, and let me take this theta node also with electric field so that there is no confusion. Okay, here there is confusion. What I can do is, let me write it again here. Let me draw it again here so that you are not confused. The electric field line was like this, and initially the dipole was like this, and now the dipole is rotated like this. Okay, and to some angle, final angle, that was, let us take some angle theta naught. Initially it was at 90 degree, so it goes from 90 to theta naught. This is how we can find the work done. We know the formula tau dot d theta. So here integration of sin theta is minus cos theta. Limit goes from 90 to theta naught. So this becomes minus PE cos theta naught minus cos 90. And this work, where this work is going? This work is stored in the potential energy, because I am rotating very slowly. There is no gain in kinetic energy. Where that work is going? That work is stored in potential energy. So this is equal to change in potential energy. So final potential energy minus initial potential energy. This initial potential energy at 90 degree, final potential energy at theta naught. I am taking 90 degree as a reference. So the potential energy at 90 degree, I am considering this to be 0. I am considering this to be 0. This is taken as a reference. This is my reference. You remember that when in work power energy, when we used to write the equation, so what we say, this is the reference level. Okay, here we are considering that the potential energy is 0, above high touch potential energy mgh, below high touch potential energy minus mgh. So there is some reference. So this is considered as reference. So potential energy here, U final at any angle theta naught is coming as minus PE cos theta naught, because cos 90 is again 0. So the formula for any particular angle theta, the potential energy is coming as minus PE cos theta for any angle theta, and minus P cos theta you can write as minus P dot E. So potential energy formula comes out to be minus P dot E. Okay, so this is, I'll say, important formula, should remember it. Got it? Not that difficult? Yeah. Work done in rotation of dipole in uniform electric field. So we just did that derivation. So I'll just write here that work done is equal to change in potential energy, and this is my final potential energy minus initial potential energy. And what is potential energy at an angle theta? That is minus P dot E. Got it? This is how we will find work done. Okay, now short dipole in non-uniform electric field. Let us take some non-uniform electric field is there, and if I ask you how much force will be there on this short dipole, how will you find that? Okay, so if I write the potential energy, that is minus of P dot E. Okay, and if I ask you what is force, how force is related to potential energy, you will say we know the formula, F is equals to minus du by dr. F is equals to minus du by dr. Simple. So you'll say this is minus d by dr of minus p dot e. Okay, so the force that comes is p dE by dr dot. Okay, so this is the expression for force in a non-uniform electric field. So whatever may be this electric field may be due to a uniformly charged wire, or let us take some other configuration, the electric field is changing, so you just do P into dot dE by dr. Let us take an example for this. If let us take two dipoles are there, this is dipole P1, this is dipole P2. If I ask you how much is the force between them, so we'll use this formula. We'll say, okay, let me find force on P2 due to P1. It's same as on P1 due to P2. Okay, on P2 if I find, so I'll write P2 into, so d by dr, that is in the same direction, so dot anyways need not take, so cos 0 is 1, into d by dr. What is the electric field due to this? Let us take this separation is r. So d by dr of 2k P1 by r cube. Because this is along the axial line, so differentiate it, you will get the force. Is it important? No, this is not that important. Okay, so just for the conceptual understanding I am telling you. So this is not generally asked in JEE means. Not that important. Okay, now let us come to some questions. Let us read it out. Two ideal electric dipoles A and B having their dipole moment P1, P2 respectively are placed on plane with their centers at O as shown. Okay, so their center is at O. At point C, the axis of dipole A and the resultant electric field is making an angle 37 degree with axis. The ratio of dipole moment of A and B is. Now, two dipoles are there. You need to find the resultant electric field. How will you find? Right electric field due to first dipole, right electric field due to second dipole, take the resultant of the two. Principle of superposition. Okay. So, right electric field due to the first dipole, this is P1. Which one is P1 by the way? AB is P1. Okay. So, this is P1, this is P2. Now, let us take this distance is r. So, if I write due to P1, what it will be on the axial line? 2k P1 by r cube. 2k P1 by r cube. Due to P2 if I write minus Kp by r, because this is on equatorial, so minus P2 is in the downward direction, so minus Kp2 by r cube, in the upward direction it will be, so Kp2 by r cube. These two electric fields we have to take the resultant will come in this direction, and that angle is making 37 degree with the axis. So this angle is 37 degree. Now here I can write tan 37 is equal to the vertical component divided by the horizontal component. Okay. So if I write tan 37, this is the vertical component, that is Kp2 by r cube divided by the horizontal component. What is that? 2Kp1 by r cube. So k by r cube, this part is getting cancelled. Let me cancel it. K is getting cancelled, by r cube is getting cancelled. So what we are getting, tan 37, that is 3 by 4 is equal to P2 by 2 P1. And this becomes 3 by 2. From there I got what we have to find, P1 by P2, that will become 2 by 3. So P1 by P2 is 2 by 3. Let me check if I did any mistake here. Tan 37, this is 2k P1, AB, which one is by the way? A and B. Okay. So first one was P1. Okay, this was P1. Okay, this was P2. Kp1, Kp2 by r cube. Yeah. at O as shown. At point C on the axis, the dipole resultant electric field is making 37 degree with the axis. Okay. Okay, this is 37. This becomes P2 by P1. Everything is fine. Yeah, because sometime what happens, this ratio is 2 by 3. There is option 3 by 2 also. So we need to check whether we did any mistake or not. Okay, therefore I was checking that. Sometimes we have to do in means also. We are doing things very quickly, but like P1 by P2 is asked, we marked P2 by P1, or P1 by P2 ratio we mentioned incorrectly. So it happens sometimes. Anyways, you got the point. So this is our next question. Let us read it out. A dipole comprises of two charged particles of identical magnitude q and opposite in nature. Okay, one q, another minus q. Certainly a dipole is like that. So one q, one minus q and another q. Let us take, it is like this. The mass m of the positive charge particle is half of the mass of negative charge particle. Positive charge particle mass is given as m, and this is half of the negative, so this is 2m. The two charges are separated by a distance L. The distance between the two is L. Okay. If the dipole is placed in uniform electric field E such a way that the dipole makes a very small angle with electric field, the angular frequency of the oscillation is. Now here again I will say, will displace by a small angle theta, the torque will write as Pe sin theta. Theta is small, so sin theta I can write as theta. This is I into alpha. For angular oscillation, alpha is minus omega square theta. Here also minus is there because restoring torque it is. So from there we got omega as root of Pe by I. This is my omega. So basically I have to write P and I have to write moment of inertia. Now both the masses are different. I have to write here the moment of inertia about the center of mass. Okay, center of mass is my inertial frame of reference here. Okay, so about center of mass, where the center of mass will be, this is mass 2m, this is m. So from here if I find the position of center of mass, so that will become m L divided by 2m plus m, that is 3m. So that is L by 3. So the center of mass is here. This is my center of mass. And this distance is L by 3. So about this if I write moment of inertia I, so that will become 2m into this square L by 3 square plus m into 2L by 3 square. Okay, so from here if I take ml square common, so what it will become here? This will become 2 by 9 plus 4 by 9. So this will become 6 by 9. So 6 by 9 ml square, which is 2 by 3 ml square. And what is my P? P is Q into L. P is Q into L. So simply put it here. So omega will become root of P, that is Q into L, into E divided by I, that is 2 by 3 ml square. So 1L is getting cancelled here. So this will become 3 by 2 QE by ml. 3 by 2 QE by ml, that is option C. Okay, so here the important point was, the masses are different, you need to write the moment of inertia about the center of mass. That is our initial frame of reference. And about that we wrote the torque, and that torque is equals to my I into alpha. From there I wrote alpha as omega square theta. From there I got omega. Another question, let us read it out. Two charges each of magnitude 0.01 Coulomb and separated by distance 0.4 mm constitute an electric dipole. If the dipole is placed in uniform electric field E, that is 10 dyne per coulomb, making an angle 30 degree, the magnitude of torque on dipole is. Now this is a simple formula based question. Torque he is asking, I'll say torque as Pe sin theta. But the problem is, here you need to convert everything to SI units. That is the problem here. Okay. So first, magnitude, first writing P. P is Q into L. So what is Q? Q is this. What is L? L is this. So Q is 0.01 into L is 0.4 and this is in mm, so 10 to the power minus 3. So this becomes my P. This is my P first. Now E, 10 dyne per coulomb. You have to convert that to SI units. Okay. So 10 dyne per, you need to convert that to Newton per coulomb. So it will become 10 into 10 to the power minus 5. Got it? This is how we convert dyne to Newton. Yeah. Making an angle 30 degrees, sine 30, that is 1 by 2. Okay. Now what it will become? 2, this will become 0.2, 10 to the power 3, minus 3, minus 3, minus 6. This will become minus 10, 10 to the power minus 10, isn't it? This is 4 and this is 3 and 3, 6. So 10 to the power 6 plus 4, 10. So minus 10 it is becoming. So 2 into 10 to the power minus 10. Only one option B. Because here you see only one option is having 2. Even numerically, if you are even confused with converting, you can still mark the correct answer. But you should understand how to convert the units. Basically these dyne and other things, you should be familiar with them. Let us do another question. What is asked here? An electric dipole moment P, okay, is at origin. The electric field due to this dipole at this particular point, and here the most important thing is r dot p is 0 is parallel to. So we need to tell to which the electric field is parallel to, not exactly the electric field. He is not asking the electric field, okay, he is not asking the electric field, he is asking the electric field is parallel to which of the vector. Now r dot p is 0. If p is like this is equatorial plane, your point where you need to find the electric field is somewhat like this on the perpendicular bisector, then only r dot p is 0. If a point is there on the perpendicular bisector, what is the formula for electric field? Minus kp by r cube, that is in the opposite direction of p. If p is along this vector, my electric field should be along minus p. So minus of this you take, that is I cap plus 3j cap minus 2k cap. It should be along this. I took minus of that. So it should be along this. Now check which vector it is. A option. Minus I cap plus 3j cap minus 2k cap. Yes, A is the correct match here. Got it? Next question. An electric field of 1000 volt per meter is applied to an electric dipole at angle of 45 degree. The value of electric dipole moment is this. The potential energy of the electric dipole is. Now we need to find potential energy. We know the formula of potential energy. We'll write the formula directly. U, that is minus of P dot E. Simple. P dot E means PE cos theta. So minus PE cos theta. Okay. So what is P there? Electric dipole moment is given 10 to the power minus 29. What is E? Electric field, that is 1000. So 10 to the power 3. PE cos of 45. Cos of 45 is 1 by root 2. So this will become 1 by root 2 into 10 to the power minus 26. Yes. So 1 by root 2 is nearly 0.7. So I can write this as 7 into 10 to the power minus 27 joules, because this is the energy, and whether it is positive or negative, minus, 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 I missed minus, yeah, here also minus, here also minus, so only B is the correct option here. Okay, so this is all from my side. We tried to cover everything, every single concept from this chapter, and hopefully we have covered all of them. We did so many varieties of questions. I tried to make the collection such that no concept is missing. Okay. If I hope that all the concepts we have covered with proper examples, so many questions we took. Now, after this class, you can get all these class notes in the description. The link is there in the description. Okay, you click that link, you'll go to our app, and PW app, as you know, is a great platform where so many students prepare for competitive exams. So from there, when you click that, you'll join our free batch, and in that free batch you'll get the notes as well as the DPPs. Now, just seeing me how I am solving questions, that is okay, you are understanding the concepts, but the most important thing is you should be able to solve the questions, not that I am solving and you are understanding. You should be able to solve the questions. So the DPPs is a very good collections of the questions, and these are the type of questions that NT asks. And if you have solved the assignments or DPPs of the previous video, write solved in the comment section. We'll meet in the next video. Thank you.